All right, now we're live on YouTube. So everybody behave. Stop talking trash about all those YouTube people. The YouTube people watch on YouTube. You guys can't talk smack about them because they're here. They're here. They're right behind you, aren't they? This cell phone format thing is really throwing me off. When I look over there, there's two videos, and one of them is me smushed up against the side of the screen because of the slight asymmetry that I like to have for this scene. For this scene, I like to have just a little bit of asymmetry. I think it adds a little character to everything. But as a result, I am all smashed up against the edge of the phone. Because the phone, like look at all this space. The phone is like this. It's like a slice. It's like a vertical slice of the screen, just right there. That's it. That's all the phone sees. Anything outside of that little slice is gone. It's such a just terrible, awful format. Why did people decide to hold their phones like this when recording something, when you could just turn it 90 degrees? You could just, hey, look, it's me. I'm filming something now. This is not where our vision focuses. It's this. I know it's nice to be able to hold your phone like this and watch the video, but man, making these wider and taller was a bad call. I hate the direction it all went in, and I blame TikTok primarily for it, for popularizing it once again when we were working so hard to kill vertical format video filming. Get more information. Done. Unless you're filming a tree, like, stupid. It's just, man, we failed as a society. we failed. This is a brutal societal failure. I'm gonna look up circuits before I spring a gasket. Yeah, these are some of the ones that we have to build still. What I need is I need a eurorack, or no, audio to eurorack circuit, not a device. It seems to be like $50 for one of those, and I'm not going to spend that money. All kinds of DIY. See, I mean, this is basically what I need. So it's audio out to the modules, audio in from the modules, line level input from tools, and then line level output to tools. And instead of the keyboard and the mixer here, we would basically just have a thingy-wingy Focusrite 2i2. It's funny, the guy who reviews all the terrible gear that I think Cyanocat linked me to in the Discord, and I enjoy his YouTube videos very much. He's got reviews of just about every piece of equipment now. He must know somebody at a music store or something. He even reviewed the 505 and commented on its hidden second oscillator that I discovered very quickly into altering my own sounds, my own sound banks on that. I'm like, where is that coming from? Because there was this ooh, there was this what do you call it? Vibrato coming from somewhere, and I'm like, where is that vibrato? And apparently, it's a second oscillator that's hiding. It's a hidden second oscillator in the 505. But anyway, so he was doing his little audio review stuff, and he did a review today about boring gear. And that resonates with me very deeply because boring gear is good gear. And having your sound response be flat is good because you're hearing what's in the recording. You're there primarily not for the purposes of enjoyment, but for the purposes of analysis, analyzing your audio and stuff. And so the gear that he talked about were the exact same studio monitors that I have, the Oxygen keyboard that's sitting behind me a little ways. I don't know which, it's the German guy. Is that Audio Pills? I forget the name of the channel. But he does reviews terrible gear, yeah. And then the Focusrite 2i2. It's the four pieces of equipment out of like 8 that he reviewed were pieces of equipment that I use. Yeah, I think he's baking his own memes, right? Because I've looked at the audio subreddits and their discourse is not that quick. I think he's making them on his own. Not a lot of circuits here. I'm looking for circuits. It's possible that I'd have to rifle through some of the mutable instruments stuff in order to find what I'm looking for. Does mutables have something that does? Do they have something that attenuates for audio level? Like volts? Elements, streams, shades, branches, shells, expander, bag of cables, links, perhaps? One to three, buffered mult. CV to distribute 3 VCOs with a voltage drop. 2 input summer, 3 input mixer. No, that's not it. That's a decent piece of equipment. And there's nothing about volts. Maybe it's in legacy. DCOs, digital design, PCB panels, education, EMC, exponential conversion, digital oscillators. Wow, there's a lot of stuff here. Audio samples received in codec resistant to DMA controller. What is that? Oh, that's something weird. Timing and processes. Why did color knobs disappear? Trivia and history. Clouds history. I need to know the history of my modules? Hey, what's up, Weaselbox? How you doing? Oh yeah, we need to get YouTube chat up here. Hopefully nobody said anything. Oh, we had Akita. How you doing? How's it going? All right, no more Twitch issues today. I came over here for the tunes. The stuff that I play at the beginning of stream. A lot of it is this. The Deckard Ripecast probably from 10 years ago is usually when I'm playing stuff. Yeah, these are good. The Ripecast is something that you should definitely look up if you like the tunes. They do a lot of tech house, but I'm here for the wallpaper music. I like something that can, you know, trip hop, that can go in the background, and having somebody else curate it is nice. Who did I used to play? What was their name? Oh man, I ran into them their name the other day. It was the guy out of New York City. He was awesome. He played a lot of really good tech house and was generally a bro. No longer does anything on Twitch. They probably, after the pandemic, they have more physical gigs to get to. So instead of streaming, it's sad. It's sad. It was a cool stream, but so I've gone back to the Ripecast. All my music is like dried up. I don't know where any music is or what to play or how to have taste, how to have opinions about music. I am broken. I am broken and I don't know how to fix it. But the way I'm going to fix it is with soldering. I'm going to make a lot of... I have weird taste in music and my patience is low. That reminds me almost immediately of Julian. And I was sad to hear Julian was like, yeah, I listen to a lot of metal now. And I'm like, come on, man. There's a lot of metal. There's a lot of heavy metal out there to listen to. And there's a lot of really cool stuff. And those guys are awesome. I love them all. But man, it seems very generic to be listening to that kind of stuff. I don't know. You like what you like. It's fine. It's all fine. There's some really good metal musicians, but there's also just a lot of metal out there. But yeah, I have kind of a weird ear. And going back, Julian has been super duper duper opinionated about what music he actually listens to. And I think a lot of it revolves around the repetitiveness of drums. I think he likes a very complex drum line in the stuff that he listens to. And so I appreciate that very greatly. But very close to my taste in music is the stuff that Flatulent Gonad is usually playing, which is stuff from the early to mid 2000s, back when the electronic music was booming. There's a lot of good stuff out there. But yeah, there's a lot of really great metal. I don't mean to put down metal, but it's just kind of funny to hear like, yeah, I just listen to metal now. It's like, what? I would think that the metal that he listens to is probably pretty crazy stuff, because I like a bit of metal sometimes. Yeah, it's nothing against it. It's just, it seems like everybody and their dog is listening to just heavy metal and that's it. That's it. That's all they're listening to. These guys out of Scandinavia, they're, yeah. Burnout from when I was at the record label. Oh, I see. Gabber with it's nice for an hour. I can't listen. I can't do Gabber. I can't do Gabber. It's okay. I can do it maybe just like a drop of it every now and then. It's like adrenochrome. It's like my body was not meant to function at the level of Gabber. You like Gabber? Okay, well there's that. There's that. Where's the legacy stuff? There was legacy stuff down here, like the module tester. That's what I was looking for. Oh, I probably should have looked at STM32 miscellaneous. Yeah. At the time I got into it in 2012, there were two choices, STM32 and NXP LPC. Freescale Kinetics wasn't available at the time. So the embedded system, more importantly, the embedded systems class of my alma mater used them. Oh man, I wish I had a good embedded systems class. Ours was kind of bad. It's probably better now. Caleb signing. I have a riddle for you. What rhymes with heart? And then they set off a fart noise. Congratulations. Oh, that's the wrong. Sorry, I clicked on the wrong thing. Box STM32 at the time. Yeah, so this is, I should probably read this sometime. It probably justifies the choice of STM32. Other than the fact that STM32 is just friggin' a crazy, crazy microcontroller. What does this one do? CS80 style sawtooth with a notch. Morphing between triangle, sawtooth, wave, square, pulse, character control. Cool. I'm looking for a mutable instrument circuit that attenuates audio for your line level audio. I'm looking for something that will do this without having to buy a $200 module. These are the eurorack basics. I need that in order to test the MS-22 that we were looking at yesterday. I just want the image. I don't want the link. Open image in new tab. That's all I want to open right now is that. That's what I'm looking for. I need both of those pieces, and I'm going to probably put them together on a breadboard, and I'm wondering if any mutable instruments modules do that. At least I didn't ask what rhymes with kiss. Subscription to my channel? That's all I can think of that rhymes with kiss. So yeah, I'm probably going to build it out of TL074s and just make the most basic one-to-one thing. What's up, Swizzle Circuits? How you doing? We're going to try to do a little bit of soldering because today is Friday and I don't feel like thinking at all. We're not going to bring in fast Fourier transfers, at least at first. You're terrible. I hesitate to ask what's wrong because we don't really want trauma dumps here. I don't want a trauma dump to start off my Friday. But I know you can get through it. There we go. That's what I'm supposed to say. 3 generators with a mixer. No, not what I'm looking for. I have a feeling it would have more of a utilitarian name. Stages. Nope. Branches, nah. Clouds, nah. Ears? Ears? Oh, that's a unique one. Built-in contact microphone soldered right to the front panel. No, don't need that. Everything's beautiful and nothing hurts. Oh, that's good. Wait, does that mean you're on your final legs? I finally don't feel anything at all. Dies. I'm gonna do it again. I have free hugs if anybody needs them. There we go. Nah, man, I'm all good. Hope you're all good. Sounds like Swizzle's all good. Yay, FFTs! Nobody knew what the hell I was talking about yesterday with the fast Fourier transform, and I tried to explain it, and I was like, it's the area under the curve? But basically, a fast Fourier transform is a way you look at all of the frequencies that are in a signal at one time. So instead of a time axis, you have a frequency axis. So the further right you go, the higher the frequency is, and we were looking at the peaks of the frequency as we swept through them. And so as we sweep through them, you can see the amplitude of all the frequencies, and if there's like a dip, it'll tell you something about what's going on. Like for instance, if it looks like the following, then it's not a frequency at all, and it's something else. Now, if it looks like these things that we were looking at, one that's less complicated. If it looks like this, as you move up in frequency, the amplitude goes up, spikes, flattens, goes up, spikes, and then goes down, that means you have what's called a high pass and low pass filter. So one is letting all the high frequencies pass, the other is letting all the low frequencies pass, and tamping out everything else. And so when in combination with one another, this is what the shape of the filter is. It looks like a kitty cat for all of the frequencies that you're sending it through. Yeah, this is just a picture of a cat hiding in a box. That's all. So this is what we were building yesterday. I love how the first image that I get is exactly what I'm looking for. What do you verify? Why? I just want to look at a picture of a cat. Bring it up, but make it larger. Free trial. What is it? Okay. So this is our filter. This is the filter layout. And so when you're at the lower frequencies of the kitty, it's blocking all the audio coming through, and then it lets up and you get a little bit through as you get around the ear, and then it's sort of a flat line in the middle because that's the interaction of the two filters. They seem to emphasize right where they're cutting off. It sort of boosts it a little bit. And then over at the other end, for the high frequencies, as you go up in frequencies, at the high frequencies, you get the little bump there where it actually amplifies instead of attenuates, and then it strongly attenuates out the higher frequencies from there. And so you can use that in order to shape the dynamics of the audio that's coming through. And if you alter all of the parameters of it in real time, you get some cool sounding stuff out of the other end. But yeah, that's essentially what we're looking at. What is the Dropbox? Oh, that was to get the clouds hex file. I have that now. My computer is like, please, sir, may I have some memory? So what I'm looking for is something akin to mutable instruments. Mutable instruments is Emily Gillette. They've gotten out of the synthesizer game. They decided not to do it, but they released all of their development files, and they've got all kinds of really wonderful articles and stuff explaining everything, and there's just some really nice circuits in here. It's basically the best iteration of a lot of these circuits that we have in modern eurorack synthesizer. And so I look to a lot of these circuits in order to build up the things that I use in order to build other modules and stuff like that, or design my own modules. So what we're looking for right now is something that I can use in order to pipe an external signal into the eurorack and out of the eurorack. And I was hoping that I would find something that was unadjustable, so I don't have to sit there and worry about whether or not my adjustments are all proper. Because the reason I want it to be unadjustable is because we are using it to evaluate the things that I'm building that could possibly be broken. So if I've got a module that's putting out a low signal, I don't want to be able to adjust that out unless I'm adjusting the module itself. Boom, explained. You guys now know. Tides, I know, is not it. Tides original. Tide pods. Veils, I don't think Veils is it. No, Veils isn't it. Voltage controlled amplifier. I do like these sliders with the LED in the middle. Yeah, what we're trying to do, and specifically we're trying to get Steve's MS-22 working again. And the way to do that apparently is just to follow instructions and install Ableton, which I happen to have. I happen to have Ableton on this machine. I was looking for a digital audio interface that would help me do all of the different inputs for streaming. And it turns out that OBS is actually the best one to do that. And I also bought a $700 external mixer that helped get me like a physical thing to tune the microphone. So AVX512, 3D, Vcache, and high memory bus widths make FFTs so much faster. What does any of that even mean? No, but we're looking to use the Ableton tools with the M Audio tools in order to create FFT plots that look like this. And so I can characterize the filter and make sure it looks like a kitty cat, because my oscilloscope's FFT wasn't quite, it didn't look quite right. The free version of Fist Studio, I think that's a different program, bro, of FL Studio, is pretty featured too. You just can't open files. I know. But can save them. Also can export to WAV and continue working on. Yeah, Fruity Loops Studio is pretty good. Everybody's kind of slept on it. Well, apparently my scope is like really good. Like the Rigol DHO 914. I mean, this thing is apparently pretty good for FFT stuff, and we used it yesterday. We got some good results. It wasn't quite up to snuff though. So to get this kind of data for audio, you know, Ableton with the M Audio tools, so I'm making the same noise they are. I use Python libs and USB connection. I found that the other day. I linked that in the stream projects section, but apparently you can use Python 3 and you can get into the scope to run like high level analysis, and then you can plot it using Python. And Python's apparently like, I don't know, like what is MATLAB even doing anymore, right? You can use MATLAB tools in Python as well, but I love programming Python because it's just so, when you get into it, when you get really rolling with the code with Python, it's very intuitive. You're just kind of thinking about this loop needs to do X, and you're like, wait, I just typed this loop needs to do X practically, and that's how Python, yeah. It might be slow from a programmer's, from a computer science perspective, it might be, you know, Python code is slow, but man, it's chatty, and so you could just chat your code out when you get used to programming it. What about GNU/Octave? You're making up words. You're just making up words. Those aren't real words. Oops, I hid chat. I guess that's appropriate. We'll bring them back. I hit the wrong button and chat went away, and instantly I felt better. No. So GNU and Octave, I have not played with Octave, but having like a Linux machine to do all this like clubbing around with weird interfaces is probably a good idea. That's how the STM32 stuff for the mutable instruments works. You have to spin up a virtual machine and, you know, or a Docker or something like that in order to do that. And that's cool because a lot of these sort of embedded systems tools will require you to install weird stuff, weird drivers and stuff. So it's good to keep that in its own little bathtub. But I've never used Octave or GNU tools. I would really like to get my visualizer working properly. Getting the LED screen work, etc. Take a look at nonlinear circuits. Macrame might be overkill for what you need, but the schematics are available. Yeah, let's take a look. Nonlinear. We love nonlinear. Who doesn't? Macrame. 6-channel mixer with a voltage control level and panning. It uses two SSI 2190s. I might have some SSI 2190s. Befico. Does Befico have like an output attenuator? L4. Instrument interface. I mean, that's essentially what I'm looking for. Although it's got a lot of adjustments. Maybe I'd have to get rid of the adjustments on my own if I user manual schematic V1. Woo! Oh! Okay, let's look at nonlinear and see if it's a more simple circuit. That's not going to be a more simple circuit. 2 synth level outputs, 2 line level jack outputs, and a stereo line output. And let's see, I mean, I made a mixer module for stereo mixing, but I don't think that's, I guess it's headphone level, so I guess it probably is also line level. Maybe I could look at my own schematics. I've forgotten most of that circuit. But the headphone attenuator had a couple problems. I forget what the problems were, though, at this point. I don't remember what the fix was, either. I think I took notes on it in my CAD tools. So this mixer does line out. It's huge. But the schematic for it is going to be in here. Ah, yes. Ah, yes. Adjustments. Let's see. Where's our signal in? Is that not? That's signal in. 220s. Okay. What are we doing there? Oh, geez. 27 to 100. Oh, so it's 100 to 27. 27 to 100, 100 to 27. Huh. What are we doing here? And that would be our line out. And then that's the, yeah, 2190, or it works the same way as the 11 something or other. 11390. My current instrument input is just an ancient LM358P. Ha. Yeah, I think it's gonna take the appearance of this. It's gonna look like this, although without all of the adjustment stuff. So we're not even gonna have the 2190 in there, which means 51 to 220 goes away. And I think it's after, this is what turns it back into audio. So instead we would just have a buffer if we had, well, the input wouldn't need to go into a buffer, but I'd probably have enough op amps sitting around to have a buffer. But then I think it's 100 to 27 is what we're looking for line out. And then that would just take our line in and turn it into, well, that turns it into line out. What turns it into stereo? Well, no, that takes our synthesizer, our eurorack in, and 100 to 27 ratio takes it back to the appropriate voltages for line out. My question is, do I need to put a DC offset in there in order to make it proper? If it's actual line out, it can go into the Focusrite. So then coming back from the Focusrite, we need to go into eurorack. And so I need to do the opposite, which may just be 27 to 100, but I think then I need to inject a DC offset into there. I have 2.5 volt DC producers, but I think, well, I don't know what the headphone level is, if it's 1.8 volts or... That's why I was looking for like a dedicated circuit, but it seems like everybody wants you to be able to adjust things so that you can get it to a happy audio level. And I'm not about that happy audio level because I'm evaluating my own equipment to see if it's at a happy audio level. What are we doing here? Oh God, this looks like it was done in AutoCAD. That's the right color scheme. Oh no, it's got a 555. It got 555 on it. Oh. Unfathomable. What are you people doing using these still? Get yourself away from the 555. Why would you have that in there? Baffling. Oh, are we pulsing through the LEDs or something? Weird. Weird. 5532. Holy. Up and down hearted baby. 100 to 10. A line, a his, to line, to his. Line level. Ooh, I don't know what's going on there. I don't know what's going on there. There's a lot. That's a little bit. Yeah, maybe PWM. Easy component to get. Come on, it's a classic. I could understand its use here. We're not doing anything microcontroller based. Although I can't really understand its use here. I don't know what the hell it's doing. This is confusing to me. Some kind of a counter. Or no, I think it's being used to drive a boost circuit. Yeah, so that's creating the 48 volt phantom power with an LM317. It's kind of crazy. They're using a diode, I forget whose that was. There's some name behind that, and that's how you create high voltages of DC. It had a birthday recently? Oh, huh. Yeah, so what that's doing is that's vibrating this circuit in order to create high levels of low current, high voltage DC. And the high voltage DC is 48 volts. It's not that high voltage, so these are probably pretty small components. But you see this stuff in like research setups where they need to create like huge amounts of DC voltages. I built one of these once and it didn't really work. but that's just for your differential line level 48 volts. It's probably the setup that they're using in a lot of audio equipment nowadays, because you could get this in a pretty small package. Although you probably can buy a voltage regulator that does the bucking for you, but this is or boosting rather, but not bucking. This is a boost converter. And usually you'd see it going into a coil, but I guess they didn't want to buy a coil, so instead you've got it going through a capacitor bank with diodes that'll just ramp it up and up and up and up and up and up. Crazy stuff. So that's probably what this is dealing with here, is getting that 24 volts back, you know, getting the audio out of the 24 volts. Whew. We did a little bit of that with my microphone pack. My microphone preamplifier for my lapel microphone. We did a lot of looking at circuits like this in order to make our own PCB that we put together and put inside of a little enclosure that I'm wearing on my belt, and has done me very good. It done me good all this time for one-to-one reproduction of audio. Probably could have figured out boosting my bass a little bit so I don't sound so treble, but whatever. 1M. Wow. So 10K to 1M, that's a huge... Well, what's that doing? Going through a diode for the gate, goes through some kind of a filter and another diode, and then a 3904 for trigger. Oh, okay, we're in the wrong section. I'm looking for line level output. This is too much. It's probably a really good circuit, but hoo-wee. That's an envelope. No. Preamp coming in through there. 2 audio I/O. But who knows what the hell's... okay, this is a lot. Oh, wow, they did a manual way to do this? With an LM339. Ooh. Tu rojo. Tu verde. Oh, Ed Verde. Amarillo. All right, that's distracting. I'm getting distracted. I'm trying to look up these circuits for, what's that? AI synthesis. Another from AI synthesis. Let's take a look. Let us take a look. Maybe it's not so daunting. We know nonlinear is at least going to get straight to the point. One page and this is it. Oh, that's pretty nice. What always surprised me about audio stuff is that when you have a mixer, you are literally just using a resistor to turn the volume up and down on a signal and dumping it all on one line, and that one line will then go to your output amplifier. But it is like just your mixer is just putting everybody on the same wire. It's kind of crazy. To studio right, 330 ohm resistor, and we're going through a TL074 from our potentiometer, and we're in a 10 to 10 with a little added on there, added or subtracted, 10 to 10, and then our input is 100, panel line R, board line R, board line in L, panel or board? Panel, oh, I see, panel to board, panel to pot, board line in, 680 to 100. 100 to 6, so 1 to 6. 1 to 6.8, 1 to almost 7, which would be... well, I don't know. I'm not doing math in my head. I refuse. All right, so I'll leave these up. I'll leave these up for later when I'm stewing over what I'm going to be building over the weekend. Because essentially that's what I'm trying to achieve, so that I can do the Ableton testing. All right. Oh, Cockcroft. Yeah, Cockcroft Walton generator is the use of those diodes and capacitors in order to kind of ladder up your DC voltage. But again, you need a changing signal in order to... Oh, ad break. All right, once the ad break's over, we'll get going. I don't know if we're doing 570 galore. This one is another like completely daunting build, and everything went in crooked, but I did finish it. We just need to like put it to the test. Digital filter simulator is a totally different animal. It's super cool. It's gonna sound really neato, gazebo. I like this mix. This is a good mix. I think I say that every time I get to this song. What the 570 galore is doing is it's taking in audio at unity gain, 100, 100, 100, 100. All this stuff, what is that doing? Oh, that's doing some cursed feedback. Taking in the audio. Again, 100 to 100 to 100 to 100. Why there's a star next to it is beyond me. But then 10 to 100. So actually we're bumping down the voltage suddenly. Probably to put it into some stuff to fade it in and out or something. But then we are taking 10K, 10K. This is a ladder of resistors. So every 10 kiloohms, we have another op amp that's got, what has it got? It's got stake in the game. What's it doing? Oh, see here, they forgot to put a dot down. So is that connected? Well, yes, because we're not doing four-way junctions. That's my own little clarity thing. So yeah, we're taking it in, but what we're doing is we're taking different ranges of the signal. And we're doing that with this sort of divider. And so the different ranges of the waveform, the different, I don't know, positions of the waveform, because basically you can recreate analog audio using a stack of resistors to make your different voltage levels. So you can recreate an actual sine wave doing that, and that's what this is doing. So it's basically sampling that sine wave or whatever audio is coming in at the clock rate that we're giving it on pin 9. So there's a whole clock thing, which is, oh, why is the clock coming in there? Oh, frequency input, yeah. Clock and frequency input, and then this is probably some kind of vibrator, I guess? Because it should have an internal clock. Where's the internal clock? Oh, it would be on the switch. So if you don't plug anything in, it's getting clocked by the waveform that's coming in. Oh, that's going to be a little weird. So we've got this super high speed clock coming in, and it's sampling your waveform at different voltage levels. So each of these will get a 1 or a 0, depending on whether or not we've gotten to that voltage level. It's basically like a VU meter. But it's working on a scale where it's sampling your waveform multiple different times. And so what that clock does, hey, welcome back, everybody. Welcome back from the ads. That's the ad indicator light. That's also a raid light. It would be nice if I could differentiate between the two. But anyway, the digital filter simulator, it's taking your waveform in as a clock signal, but you can also plug in an external clock if you want to have like a square wave clock. This resistor ladder is functioning to basically set off these different comparators at different voltage levels. So depending on, it's like a VU meter. As your waveform comes in, it's like the top of your waveform will set off this one and all the ones below it, and the lower waveforms will only set off the lower ones. And so when you flip that through using the clock signal, you flip-flop that over to an output. Depending on whether or not these bits are active, it will set off it'll put voltage into these different resistors here, and that will give you a approximation of a waveform on the output. So you're chopping up your waveform and you're splitting it into 4 bits. And then those 4 bits are going to the D pin. And they get flopped to A, B, C, and D. And reconstructed. And then output, and mixed together, and then output. So 1, 2, 3, and 4 give you your 4 levels of signal. They're pretty cool stuff. Pretty cool stuff. I don't know if we're going to look at digital filter simulator today, but it's pretty good. Delay no more. That's what I want to look at. So let's get started. Goodbye. Goodbye, music. Goodbye, good music. Welcome to Synthesizers. Hey, how's it going, everybody? YouTubers and Twitch viewers alike. Today we can only hope that we have stable Twitchernet. The Twitchernet fell yesterday, likely due to the GTA trailer dropping, because it was around that time. The internet just took a big shit on everybody. I saw Djibouti show try to stream, and it was harrowing, freezing every 10 seconds, and then Justin's thing would freeze, and then Twitch would freeze, and but today, for us, by the way, that did happen. We had Twitch fell, and I lost like 20 viewers, and you know, the usual. But today we should be stable. We've got all the reason to believe that Twitch is going to be perfectly fine and stable throughout the day today. I would like to change gears a little bit. Yesterday we did a lot of sort of cerebral, fast foyer transformy kind of stuff. We might end up doing that again, but I would like to do a little bit of soldering at the beginning here because I've got a couple little odds and ends that I need to kind of tie a bow on before I get to the actual testing of the modules. We were discussing before stream, we were looking at circuits. I'm going to try to build an interface for my audio stuff that'll go, like my audio interface, the audio tools on the computer, that will interface with eurorack, but I need it to be scientific. I don't need it to be sort of loosey-goosey audio guy stuff because I want to evaluate whether or not my circuits work. So I need something that's like a one-to-one eurorack to audio equipment and audio equipment to eurorack. No adjustment potentiometers or anything like that. I'm going to build it on breadboard. It'll probably just be like 2 op amps. I think that's all it's really needed in this scenario. It's 2 op amps, and then the ratio of the resistors will dictate the rest. But then again, I may need to have one of the op amps do a shift into the DC positives so that I can output line level audio. Then again, we've been seeing line level outputs. We've been looking at a couple of circuits here, from nonlinear circuits to you know, some of these other ones that you guys linked, and it didn't look like they were doing anything. The audio interface can handle plus minus 12 volts, a normal audio interface, really? I mean, I guess it does output 48 volts for powering stuff. But then I need my line level output to go to the plus minus 12 as well, so I can actually put real audio into other stuff. And so I guess that's where the amp comes in handy. More 2 M2. I have a Focusrite 2i2. And I think that does deal. Does the Focusrite 2i2, hold on, 12 volt audio, Focusrite 2i2. It's a competing product, so it should do the same stuff. Holy shit, 220 bucks? Oh, that's like the new one. I don't have that. Man, they're cranking out new versions of these things. How about 2i2 Euro rack? Isn't really built to handle audio Eurorack levels. For instance, the output of the tub to what the fuck? Can connect audio to the system 2i2 and other such modules. Don't really handle the level well. This post is flared as beginner. Okay, thanks. And then they're probably linking to exactly what I'm... Oh, Jesus Christ. No, we don't need a $300, $400... Well, anyway, I think I do need to build just a little op amp to do the signal level conversions on it. But in the meantime, I kind of want to just work on some of these filters that I have, because we got so many of these filters that oops, I've got so many of these filters that, you know, we need to actually like build some of them up so I can get to testing them. We have our digital signal simulator here, which is a pretty cool little concept. It's a neat little board. It's basically just taking your voltage levels and putting them into flip-flops, and then the clock is either determined by your signal in waveform, or you can put an external clock into this. So you can get a 555 timer and put that into here and actually make it sort of digitize your signal, and then you can kind of push that to the edge in order to make it stupid. Maybe we'll take a look at this later. We did plug it in and it seems to work, but there's always some soldering errors in the board itself. So that's something for us to take a look at more closely later. The 570 Galore, I ruined the front panel on. So we're gonna have to make our own front panel so that my potentiometers can stick out of this a little bit. But then I don't have any information on this really. I have little snippets of information on it, and I need to know how in the hell I'm going to actually test this thing to see what it does. Apparently this can like overdrive some of your stuff and make it sound really cool. It's got a compressor, expander, I don't know what AGC is, a limiter and an envelope all built into this thing. It's an LM394, and then these parts are called companders, and that's not a companda. We're not Venture Brothers. It's a expander compressor chip. I don't know exactly what it does, but the marking for all of the stuff on this was a challenge in and of itself, not to mention the density of the circuit. This all needs going over because there's probably a couple bad solder joints in there. I have seen audio out on every one but the, what do you call it? The envelope, everything but the envelope. But yeah, I tried to install these potentiometers, the 25 turn blue potentiometers. Those are the ones that everybody should use because they're so available everywhere, and they're very nice. The 25 turns is a lot of very precise adjustability in them. It's on a worm gear, so you don't lose your adjustment settings at all. But they fit with the front panel stuff, right? They are the same depth as the knockoff Alps potentiometers. They're the same height as Donkey Kong's, except the little adjustment doohickey pokes out of the front. So I tried to drill holes for them. And of course, on any kind of a panel, if you try to drill holes for stuff, they're going to be off. And every single one of my holes is completely off. You can just barely see a little bit of the adjustment thing in the corner of the hole. So I'm mad. I'm going to have to design a 3D printed one for that so that it'll just drop in and we'll have a front panel. But then we also need to figure out what in the hell we're adjusting. There's one knob. What am I adjusting? So that'll be something to look at later. I don't know what I'm doing with that one. Clouds is a manage of, they go on the back. They don't have to go on the back, man. They don't, because they're the same height as everything else. They can go on the front. I like putting them on the front so that you can actually adjust them in situ if you really need to, and it makes tuning a little bit more easy. And also you don't have a bunch of things sticking off the back of your board to catch on something and break. So yeah, I put them on the front. I know they go on the, technically in the build they go on the back, but I get to do things my way. So then clouds we know our microcontroller is not communicating with our DAC, digital and analog. There is some way, and I'll have to look it up again, to get into the settings of this mamma jamma and select what resolution you're recording in. You get 8 seconds down to 2 seconds, depending on whether you're recording in stereo or what bit rate you're recording at. And I think, and it's just a hunch, maybe because I've never selected any of the resolutions, there might not be a default, and that might be killing I2C, I2S, or whatever communication between these two because it's just not set. Because everything else seems to work with this. I can select the 4 whatever bank thingies and adjust them. We see the LEDs working and doing stuff, so our microcontroller is fine. We don't see anyone trying to communicate on I2S or I2C, so the DAC may or may not work. Nobody's trying to talk to it. We do see a couple of the clocks working, but do you say I squared C? No, because I didn't square C. Whoever did that to C is a monster. No, I say I2C. I2C, I2S. This has both, and they're not communicating. So my thoughts on that matter is that I've never used this before, and I've never selected that rate. Maybe that's what's troubling clouds. Maybe. Because it seems like everything else is working. It's kind of unfathomable that you would upload a hex file to the exact same processor and only I2S wouldn't work. Do you work on these electronic music devices on a regular basis? On a daily basis? Somewhat. Yeah, somewhat. I should have put the more modern capacitors on these. I don't like all these big through-hole capacitors sticking up out of the back of the thing. Maybe I could have used surface mount ones. Doing full duplex 24-bit I2C with a random Chinese codec right now. It's been an adventure. Oh, sorry, not I2C, I2S. Yeah, it's a hell of a thing. I'm using I2S for the module tester board over here, and it's actually the Paul Stoffrigan tools for the Teensy 4 are really, really nice. Teensy 4 will do your homework. This thing's amazing. But anyway, this was designed in 2015, so it's got an STM32 on it. And while it does have a bootloader that we can upload with, I could also, I think I have the STM interface now that I could upload with the official programmer, but it strikes me as completely unreasonable that if I program the hex into this chip and the chip is doing all of the other functions of, you know, the system stuff that it has to do, why would it then not send I2C or I2S? And I think that maybe just be configuring a setting. I think I'll have to put that to the test later. Then we have the other two filters that I'm trying to build. This push to build all these filters is from Julian coming over and going, you need a powered multi and you need more filters on your synthesizer. So I went out and I searched some circuit boards and I bought the ones that I thought were interesting. All of them $20 to $40 for the circuit board only, and then I had to get all of the other stuff. And this one was from the first bout of synthesizer building when I got a bunch of mutable instruments stuff. This thing's going to be so awesome when it works because it does some really complicated sampling stuff that sounds really good. I'll have to get a microphone for the setup too. then I can do weird voice samples and throw them into everything, throw them into the mix. But alas, this thing still unworking. The mutable instruments circuits have been really interesting for me, and they've really taught me a lot about interfacing with synthesizer stuff, because Emily Gillette, over the course of a career, sort of narrowed down the functionality that you would need in order to bring external control voltages, external triggers, and external audio into a 3.3 volt microcontroller or audio interface, and then taking those control voltages and stuff out of that 3.3 volt microcontroller and putting it back into the eurorack format. There's been a lot of really good circuit blocks that I've gotten from these Emily Gillette creations. So that being said, I've got two more filters that need our attention. One of them is a delay circuit, delay no more, this one's called. This one uses a pretty popular delay chip. It's just like an audio chip that a lot of these guitar effects pedals and eurorack, and everybody likes it. I didn't have enough connectors. I spent an inordinate amount of resources getting all of the stuff together to build these and ordering potentiometers, and turns out I was out of connectors. So let's get the connectors on here, the Thonky Cons on here. Same thing with this other nonlinear circuits. This one is the low pass gate. It's got no plugs, and I think it's missing a dual Vactrol. Dual Vactrol is like a science experiment level component. All it does is vary resistance based on light. And so this light, there's no LED. Did I not install? No, they didn't put an LED on the LED. They should put an LED on the LED so you can LED when you LED. This one has it. That LED right there is connected directly to the Vactrol. I bought some of those Vactrols. They seem, never used them. They seem neat. Yeah, I mean, it's like a $15 part. Or you can just get an LED and some of these light-dependent resistors. See, I built a singular Vactrol over there, but that one actually uses a piece of a syringe. A piece of a syringe that I used to inject insulin into my body. And it became so dull that I threw the syringe, and it turns out it is just the right diameter to get a 3mm LED in. And so on one side of that, there's an LDR, the other side is a 3mm LED, and then I shrink wrap them both in place and put a little bit of opaque hot glue into the ends. MS-20 uses plenty of those. The MS-22 does not, but the MS-20, I think, yeah. I think I was looking at some of those circuits from whatever the MS-22 is based on, but yeah, I've 3 times decided not to use Vactrols. That's kind of sad. The thing is, there's no, I've found them, but there's no like tiny surface mount equivalent of this light dependent resistor. It's kind of a, like, musicians use these, but like nobody else really does. You use it if you're trying to detect if the sun's up or not, right? Every time he says LED, we take a drink. What if I say IED? So yeah, there's no real surface mount equivalent of this thing. It would be nice because then you could have a bunch of like surface mount LEDs that are right next to. Although from what I hear, some of the PCBs will let light through enough to interrupt the Vactrol. So I guess it's better that you have a big piece of plastic. For us, we actually did use a surface mount LED. We actually did use a surface mount LED, and I made this little epoxy contraption, which is a surface mount LED with a light dependent resistor just shoved up in its face and ultraviolet glue in between. This is actually removable though. I put it on standoffs. For the dual Vactrol, I don't think I'm going to be able to do that. That requires two. I've seen some people put two of the two LEDs in parallel in order to make a Vactrol, like a dual Vactrol, but I don't know if I want to do that or if I want to just shove a singular LED in there and just have the two LDRs sitting next to it. The response curve will be weird, but apparently an orange LED is the best LED to use. What other circuit substitutions? I think I got all the right parts in this one. I don't think anything else is missing. We just need the Thonky Cons, and we need the LDR. I think those are the only two things that are missing. Why orange? Somebody did tests and they found that orange had the best spread of frequencies that apparently the light dependent resistors are sensitive to. I mean, generally the light dependent resistors you're using to detect the sun, and I guess they're looking for the dawn sun when it's orange and low in the sky. I don't know how it works out that way. That's just the formulation of the light dependent resistors that we get nowadays. White LED had a different response to it, but they were doing kind of cool tests on that. I think it's in one of these DIY synth subreddits. But yeah, that's how it worked out. I guess orange just has the favorable spread of frequencies. And they're easy to find and everything too. This one doesn't require any adjustments. There are no adjustments on it. Well, that's cool. Well, let's finish building it and we can put a signal into it and see it come back delayed, I guess. Yeah, it's a cool little experiment to run where you just hook up an LDR and you see what through the brightness of the LED, through a sweep of the brightness of the LED, you see what it responds to. I kind of messed up in my 3D models. These are too narrow. I made the holes too narrow. So I got to come in here and actually widen them out. And to do that, we use a repair ream, or I could just use a drill to do it. I don't know if I have a drill that's precisely the right size for headphone, or sorry, not headphone, for the alphas. I'll put a bunch of washers under the two so that they're the same height. These knockoff alphas that I got from Mauser are a little bit lower than their counterparts. I don't think I'll ever get over how clever I find sensors. Why do you, wait, what? They're just sensors, man. They sense stuff. I mean, whoever came up with them are probably, you know, super giant brained. I love how they work. Yeah, it is kind of cool. Sensing stuff. I guess that was kind of my whole major. Sensing and then controlling due to the results of the sensors. Because that's what, with control systems, what you're doing is you're feeding back an error back into your system. So if your error is large, that means you're far away from the numbers that you're looking for out of the output of the, or out of the entire system from your sensors. And so you need to give it some oomph in order to get to the expected value. And the way that you control the systems in between to get that expected value is sort of the study of control systems. Yeah, MEMS sensors are crazy. The fact that acceleration is literally just a couple springs and we are sensing that seems unsafe. I just hit myself with a knife there. Where's my other knife? There it is. The fact that they literally just suspend a cube on a bunch of springs and we can then incredibly accurately measure what the acceleration of a device is, that's crazy to me. And it's all etched into rock. It's etched into a substance that can be doped to either conduct or not. But then we can have a mechanical sensor on that by literally creating a floating cube whose position is sensed electronically. Microscopically. Microscopic electronic. We got plasma rifles. We got... People have been playing that new Aliens game, and all I can do is quote the movie over and over again. Every day in the Corps is like a day on the farm. Every meal's a feast. Every paycheck's a fortune. I love the Corps. I'm just getting the burr off of this. The tapered ream on PETG leaves quite a big lip, and we don't want a big lip. I just got to be careful where the knife is going and keep my hands out of the way. The knife will not be stopped. My hands, however, will. I think one could design a co-packaged Vactrol with a molded support and lead former for the THT. What the fuck am I reading? Okay, hold on, sorry. I'm going to break down whatever the fuck you just typed. I don't know what those words are. Like, I think the rule of writing documents needs to apply is that the first time you use the acronym, you have to spell it out. At least with some of this stuff, I don't know what you guys know. I think one could design a co-packaged Vactrol with a molded support and lead former for the THT parts, but aren't these mostly replaced by analog IC equivalents? I don't know. The Vactrol technology I only see in sort of the DIY stuff. So I have a feeling that there are equivalent ways of doing it that are less physical and depend less on a slow photoresistor. Photoresistors are not fast, which is why they're really good at sunlight sensing. Because sunlight, you get a lot of sunlight, enough to alter our DNA. You get enough sunlight to cook food when you get sunlight. And so you put that on your garden equipment, on your little garden gnome, so that the two lasers in the garden gnome's eyes can light up when the sun goes down. That's the good use of a photoresistor. Yeah, but if you're driving them to the bitter edge in order to create distortion and cool sounding stuff like that, then I guess the Vactrol is what you want to be using. Double exponential in response and highly distorting. I see. I mean, are we going to build a Vactrol? Well, let's do this one first. Let's do the soldering of these Thonky Cons first. Where are my Thonky Cons? Where are my Thonky Cons at? Oh, they're under here. I have to very carefully move this as not to spill the entire contents of the tray. Ooh. Okay, we barely made that. We barely did that without causing an avalanche or a labalanche. Now we're going to get to some better projects. We're going to do some stuff that's not audio eventually. Talk about putting guard in gnome. Yes. Now, I could launch into a diatribe about the proper ThonkyCon connections. Every time we solder ThonkyCons, I feel the need to educate the public on this because I've been burned before. There are, in fact, two different kinds of ThonkyCons, and I have both in this bin. The problem is I don't have a lot of the other kind. I used to show the demo of them getting destroyed, which, believe it or not, destroys them. When you show the demo of how these things destroy themselves, they destroy themselves. Water is wet. Did you guys know that water is wet? that when you get things wet, you get water on them, and then they're wet. The water itself isn't wet. It makes things wet, which is unique to water. Does the water get him, or does he get the water? I understand the water. I can't find them. They were in here. The point is, on a proper ThonkeyCon connector, and by the way, ThonkeyCon is just a name for a Chinese part. There's a different manufacturer that creates these, and they've got a boring part number. We call them ThonkeyCons because the company ThonkeyCon.co.uk decided to bring them into the mix. They're extremely useful because they are through-hole, board-level, height-appropriate, headphone-sized, 1/8 of an inch jack that is compatible with the alpha potentiometers that feel so nice, and a bunch of different other heights of panel-mounted stuff. They're very, very good for that purpose. Now, they need a little bit of clearance on the PCB itself. You need to not have a layer of copper in the very center of the connector, but the proper ones, in the item pictures, you can always see it, will have this little metal collar. And that little metal collar on the bottom is there to ensure you that the force is only going into the metal and squishing against your front panel. When you put the nut on the other side of this thing and tighten it down, all of that force is going against that little metal piece there instead of your ground coupling down here, which is a metal plate that has been riveted to the circular jack. So if you put a nut on here and there is no collar, it's putting that pressure against this plastic, and it will extrude your metal through that plate and disconnect, and it'll destroy your synthesizer that you spent so much time soldering. And I've seen it before. I've seen it many times, and I've done it myself. If you do have the other kind, it's okay. You're not going to die immediately. You won't die immediately from having the wrong kind. Maybe eventually, but you're not, you're eventually going to die. But if you have this kind, which have, actually, these are the proper kind. I just gave them a different connector. Never mind. If you, generally you'll see this nut on the improper ThonkeyCons. If you have those, only hand tighten that. Pinch it, pinch the little knurls and get that as tight as you can that way. Do not use a tool on it. When you use a tool on it, you put enough torque into it to loosen it. And of course, during the use life of your connectors, it's also going to loosen. That's something you can't be helped. You just have to get in there with your fingies and tighten it again. They sell a tool for tightening those. Don't get it. If you do get that tool, only use it for loosening, because those ThonkeyCon connectors kill themselves. They extrude. They'll just. So yeah. All plastic outgases, so you'll die eventually. I think you're going to die closer than that. Okay, so the repair ream has gotten this wide enough to actually fit on. So our LED pokes through and everything. I will cover this in vinyl later and give it proper labels so that it looks like the rest of my slate gray synthesizer. I wanted something a little different than slate gray. Slate gray is a little boring, but I guess I'm just sticking with it. All right, so when we install the ThonkeyCons, and especially with nonlinear circuits designs, these get just massive gaping holes. And the thing about massive gaping holes, I mean, we love massive gaping holes on this channel, but yeah, so it's a little imprecise for my liking. I am on literally the other end of that spectrum. Let me find one of my designs, my recent designs. Where'd that 2 HP one go? Hold on, I gotta look for a comparison here. We're gonna compare our holes. Oh, here it is. Who's, wait a minute, who's nonlinear circuits again? It's funnier if I refer to them by name. Where's he about? NLC designs and sells PCB panels for eurorack modules. All modules are analog. There are no microprocessors or MIDI. I started building DIY since in 1998. Surge clone, blah, blah, blah. Study electronics, completed diploma of electrotechnology. That's a degree you can get? Footprint library management, not one of my most favorite jobs. It is a necessary thing though, yeah. Is that AMB 127? Like Amber? But it's 4 MB. 4 MB is saying footprints are so meticulous and important, and they're not fun to work on. They are a little fun to work on, but any CAD tool that has footprint editing, it's like not intuitive, and I don't know. They could do to give you like a tree design where you have a part and then all the stuff associated with it all in one place. But Eagle was particularly bad about this. Fusion Eagle is still bad about it. It is confusing. You have to be careful what you're clicking. When you get, the mechanical CAD brain, when you get the mechanical CAD brain going and you've gone over all of your parts, there is just this nirvanic bliss about just being able to throw a bunch of parts down on a board, connect all the things and hit print and know that you're getting something in the mail. That's exactly what you set out to get, but it takes curating. You got to do that job. That is one of the most important things, something I stress, is making sure that your group of parts, they're your babies. That's like your lifeblood. And it should be worth a lot more. For me, I haven't made any money off of my parts layouts. That's sort of a failing of Oh Bother. That's something that Oh Bother needs to get better at, is actually, getting paid at the end of the day. But I've put a lot of work into these parts models and stuff. And I guess I could put them up on GitHub at some point for other people to benefit from. But I'm trying to figure out who NLC is. Where's like the about page? What is this chap's name? You guys know. Who are you? Is it JC Sprott? No, that's Inspiration. Builder's Guide. Can I make my own PCBs from your designs? Of course. Can I make my own PCBs from your designs and sell the extras? No. I should just call him Steve, but I wanted to get a first name. Randy helps out. I came here for the dog. Ah! Dog. 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 Andrew Fitch is the name? Cool. Okay, so we can call him Andrew now. Or I could say Fitch. That would be actually pretty good too. Anyway, Fitch's part, Andrew's part, is on one end of the scale. The sort of loosey-goosey, anything goes end of the scale. Oh Bother's part is a little bit tighter than that, and this is actually what they specify in the spec for the ThonkyCon connector. This mixer, I'm so pissed off at this mixer because there's another British mixer that does this with way less parts. I had a lot of parts going in on this thing. I had this headphone amplifier, these sort of pretty advanced op amps that weren't as good as TL074s and are now discontinued, and the LM13700s, in order to make a stereo amplifier, a stereo mixer that had line level inputs. Yeah, this is a design from a little while ago. It was for Julian on his goading to make this part. And then we discovered that there was a $50 module that did this anyway. I think there's one correction that I made in this thing. I don't remember where. I'm wondering, I don't know if this would work for the thing that I wanted to do with line level inputs and outputs, but I've made 2 eurorack boards. This is one of them, and the other one is this one that I just got, which is a powered multi. And that just has TL074 amplifiers, but it's got my super compact layout. In order to fit these, I have to cut the leads and flatten them. So there's an actual build order for this. But the problem is, I made it so that the first plug will, if you plug this one in, or if you plug the other input in, all of the outputs will be on that input. If you plug 2 inputs in, the one that you plug in here does the bottom 3, and the one that you plug in midway does the top 3. So in its broken state, it does not do what it should do. I've made the corrections in CAD. I just have to order the boards, and then I'd have 10 of these powered mults. I think Julian is champing at the bit to get some. Julian's my music producer friend. He's a Zelikovich on YouTube. Z-E-L-I, wait, hold on. Zelikovic. Those are all his links. Yeah, he's the one who goaded me for 20 years to get me to build a synthesizer. So that's why we're not working on Burn the Subs. We're just sitting behind me. We are working on synthesizers because this has been 20 years in the making. I need to give it a proper amount of time and learn all of these analog and digital concepts that go into this kind of stuff so that I can repair his shit that keeps breaking. The M303 is still sitting. I have a pair of M303s still sitting behind me in a state of disrepair. So yeah, Andrew Fitch and myself are on two ends of the design spectrum. I'm cramming as much stuff as I can into a small area, whereas he's basically just like running and gunning, creating these circuits out of stuff that he has in a closet. Pretty amazing. Faust is pretty good for prototyping DSP. I've heard of that, but I don't know. Yeah, I haven't used anything like that. All right, so these pots always come with a ton of these washers. So I think I'm going to build up a couple washers on these two in order to create that height, because these are just extras. I don't really use these. Yeah, because I can make just a little spacer out of that. So my front panel fits on evenly. Actually, I think that's perfect. I think two of those is exactly the height that I need. Wait, what? All right, first off, these seem to be leaning to the side. That's something that I can't really fix. Where are they leaning to the side? What the hell? I guess they're okay. But this isn't sitting flat. Oh, because I've still got a nub. So they have this little nub to keep the thing from spinning. Spinning. Like this. To keep them from spinning in place, but it's not really necessary when we've got so many of them and they're connected to a front panel and a PCB. So oftentimes they will have you clipping these off to flatten the front. And this metal is pretty cheap and soft. I'm not too concerned about using my super nice Nipex that I use for flush cutting a lot of stuff. I'm okay using it for that. Let's see if these washers make up the difference here. So those are all flat. Those are all flat. These, they're close. I think they need another one. And then we'll install the Funky Cons, and that will allow us to solder them in place with such big, slidey footprints. I'm going to have to buy knobs at some point, too. Proper use of champing at the bit rather than chomping. Those are the things that, like, that's going to get me Ted Bundy'd. My brother's going to hear that and, like, be like, wait a minute. Everybody says chomping at the bit. That's my brother in a shack somewhere in the woods. Does he still own his shack, though? The Unabomber? Because they have his shack at the FBI. So, like, if he didn't die in prison and he got out, could he have been like, can I get my shack back, please? I guess it's probably seized property, but they got the whole damn thing sitting in a warehouse. And it's like, dude, that's mine. I kind of need it back to, like, live in. Why is it still sticking up? I think the LED is poking out. So we install these without soldering them, and that way these giant plugs, they'll still have the pin kind of sitting in the middle there, but that'll actually help us to get everything lined up properly. So what I'm going to do right now is I'm just going to heat up these LED leads while pushing down on it. Actually, there's no solder on there. I'm going to load up a bunch of solder onto this. Anyway, so now everybody is introed to all the musical stuff that I've had going on, huh? We got a couple modules here to test and build, but I do want to get back to Burn the Subs. But again, like I said, I mean, it's really only Smith Clay has been on my ass about this, but I need to get back to Burn the Subs because that's my obligation to you, Twitch. Because Burn the Subs was my interactive thing, and that's what got me partnered in the first place, was having this gloriously interactable board on my wall, what burned the names of subscribers onto a giant board. But I've taken it aside for music stuff for several years now, after getting quite a bit done with the board. We've taken it aside for the synthesizer stuff because I've owed Julian a promise for over 20 years that I would get to this stuff. So, what's up, Shadowcat? At least we can still fart. Yeah, you guys can still fart. And I've been meaning to give you guys other interactions. The problem is my health insurance is tied to my income, and I'm a type 1 diabetic, so health insurance is pretty important. I've been saying for years, and I think people are only just starting to wake up to the fact that there is it's a form of indentured servitude where I have to have insurance or I die, which is kind of sucks, huh? I have to have health insurance or I literally will die, because there's no way in hell I would be able to afford, oh, I see, I put it on the wrong ones. There's no way I'd be able to afford my level of care and management of diabetes, which, by the way, is doing extremely well, better than my entire life. It's been doing extremely well with the automated stuff that I've implemented. The feedback loop from a glucose sensor going into a disposable on-the-body pump so that I can move around about my day, do whatever I need to do, and have insulin being delivered during such activities. Oh, it's actually too big now. Okay. So I need fewer of these. So yeah, if I do the money gun, I would attach that to donations, because it's like such and such gave $20, and then the money gun hits me with $20 physically, right? That's the funny part. Just tying it to channel points would be kind of annoying and not worth my time playing 52 pickup all day with dollar bills, but it would be very funny. And so as soon as I activate that, it's going to start to threaten my my life, my situation, I guess I should say. That's still sticking up weirdly. Now, I know these aren't the same height, and I think it's because these things are sprung, so maybe I am good to put some of the bolts on. Where are the bolts? They're all over here. I need to at least get a couple of these on so that it holds on to the front panel. I'm trying to fish out these little guys. Oh, here they are. That old bag of them. Bang. Health is wealth, father. I guess. I don't have that second part. Yeah, I'd have to make it big suddenly. It's not really gonna happen. Where did that? I put it away. I put it away. Oh. In your anger, you put away the one tool you needed. No. Okay, this one. I think it's you. Yeah, that's about right. I know that you have love-hate with us. Analog guitar pedal crowd. Not really. Not love-hate. Indifference, maybe. I think you'd have a viewership ready and waiting on clones and mods alone from the analytical side. Huh. For guitar pedals? Interesting. Because, like, they say that about Eurorack, and while there are a couple... Oh, we got 2 minutes until an ad. Two minutes until an ad. Yeah, so I don't know, like guitar pedal stuff I haven't really delved into, but it's apparently very similar to all the Eurorack stuff. Not just tone, but the science behind it. Interesting. Oh, can this one even screw in? It's like these washers are kind of being springs. That's not really... Yeah, I wonder how much I could bring to the table in terms of like circuit analysis and stuff, because as much as I sort of deprecate my own level of skill, I do know some things now. Whether or not that's enough to be dangerous, yet to be seen, but come on, bite in on something. Oh, I should be going into the bag for this. For some reason, distortion pedals are pretty rare as eurorack modules. Pretty rare as eurorack modules. Proco-Rat at least makes a very fun effect. Why would but I thought distortion was one of those primary guitar sounds that everybody goes for. That's what it's all about. I think that's what the 570 Galore does too. And the 570 Galore, I don't really have a proper schematic for this thing here. I don't really have a schematic for it, which is going to make troubleshooting utter hell. Did somebody link me to a 570 Galore schematic? I'm trying to remember. Or is there one in this Google Docs manual? That's the one that people linked me to. Hold on one sec. I'll just try to get this last one. These washers are kind of spring washers. They're like a little bit concave in order to provide like spring force to try to keep everything together. I don't really think they're strictly necessary when it comes to these potentiometers, but this one, the threads are so low on it that I need the springs to spring down a little bit so I can get that barely a thread that's sitting there. Your circuit analysis is lovely. I've enjoyed your streams because you understand a lot of stuff. Oh, thank you. It's hard to tell if you're, because the chat will always jump in if you accidentally contradict yourself. And so I'm more aware. I think I just cross-threaded it. That one doesn't get a bolt. That one doesn't get a bolt. There's not enough thread. There's 2 threads. Oh, ad break. Ad break. I think a lot of the circuit analysis just stems from me living in this stuff for a long time and knowing the English language. I always thought that my high school was absolutely insane for the stress that they put on English grammar, but it turns out it probably wasn't misplaced. These don't fit because there's through-hole devices on the other side. What the fuck? Oh, linear, non-linear. I think we can tolerate this being a little weird. I think we can tolerate it. It's just a little bit smunched. I'll just clean up the desk while I wait for the ad to progress. We've got about a minute and 50 seconds. I spent all week going through LEDs as clipping diodes, trying to figure out the best option for a particular pedal. Just to indicate that something is clipping. Well, what's the, color scheme? You got one of those, get one of those like 5mm diodes. The main difference is Eurorack is so effing loud output level wise. Well, the output levels being where they are, they can't drive anything, right? They can't really drive like a physical speaker. If you plug your headphones into Eurorack, you risk burning out the connections in it, but you'll hear very quiet music, very, very accurately presented because that coil's being driven with so many volts. Yeah, Eurorack, it's not so much that it's loud, it's that there's a ton of amplitude on the signal so that you can represent tiny, tiny variances and stuff with high accuracy. That's sort of the whole ethos of Eurorack. Is that you got plus minus like 10-ish volts for your audio signals to play in. Da, 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 da. All right, so we are putting together a delay, which I don't know what that's going to look like on the scope. I don't really have audio that I can pipe into these filters. I'm going to work on that over the weekend. I'm going to put together the, chewy, chocolatey, crunchy Hershey's. I'm going to put together my one-to-one interface for getting in and out of the Focusrite 2i2. Oh, we're almost back from the ad. We were talking about almost nothing. I was basically getting compliments from chat, which is kind of feels weird, doesn't it? Anyway, we're back from an ad. Welcome back, everybody. We're still doing what we were doing before. I'm putting together a front panel so that all of my stuff is in the right place so we can dump a ton of solder on it and get the proper ThonkyCon connector onto the front panel in the right position. But it turns out Andrew, whose last name I now forget, of Nonlinear Circuits, put a bunch of through-hole stuff right next to the ThonkyCon connectors, much to my chagrin, and it causes... Why can't we get a good shot of this? Probably because it's dark. It's dark and evil and edgy. Ooh, I'm so dark and edgy. Ooh, look at me. I think maybe I need to correct this in my CAD file by spacing it out a little bit more. But like, you can see the connectors all the way to the left there because this TL07, 78L05. By the way, 7805 is every other variation of package. 78L05 is the little TO92 one. This one right here, 78L05. You won't really find much if you look up 7805 for this package. You need the 78L. Weird, right? So my holes probably need to be stretched out a little bit. But also, I don't know, these are adjacent to these through holes that are pushing them away and not allowing them to sort of scooch up on the holes that I made. Yeah, it's a 78 low power 05. Whatever goes on under the hood, it doesn't matter. You give it input power and ground and it gets hot and it creates the right voltage for you. But the 78L05 doesn't have as much oomph as its counterparts. Actually, it has more oomph than some and less than others. It depends on the package. I'm going to allow this one to be a little bit janky, but I'm going to have to go back into CAD and fix that. Yeah, that's 12 volts to 5 volts. Generally, even though the power specification for eurorack includes a 5-volt rail, people are going to use the 10-pin connector, the 10-pin IDC connector, to have plus and minus 12 volts on either end and all your grounds in the middle. That way you can do trickery with diodes in order to keep you from blowing up your own device. And if you plug it in backwards, you know what you're going to get, just as long as your negative 12-volt rail is tolerant of plus 12 volts. But yeah, most places are going to use that 10-pin connector mostly to save space, and because you can create 5 volts from the 12 volts very, very easy. So if you're actually speccing out a power supply for your eurorack equipment, you generally beef up that positive 12. You don't need much with negative 12 because it's generally only being used as a reference. It's not being used to drive LEDs and stuff. But that 12 volts is going to be your primary customer for all of the power of your devices. So that's the one you beef up. Negative 12 volts doesn't need nearly as much oomph as the other two. That song's stuck in my head. Oh, I don't know the lyrics either. I don't know the lyrics, and it's stuck in my head. Story of my life. All right, those are relatively good. They're still kind of shitty back here, but we're going to ignore that. We're just going to put that out of our minds. A shrouded connector with a key would fit in that space. Shrouded connector with a key. That is too close. Who has a shroud? You have a shroud. The shroud sticks out on the two sides a lot. So if I installed the capacitor on the other side, maybe used a surface mount capacitor that was sort of similar in value, maybe I'd get away with it, but no, it's too big and wide. I think eventually Andrew learned and moved stuff away, but no. Shroud is a streamer a shrouded connector with a keyway. So what they said is that, bother, instead of this stupid looking breakaway header that just has a piece of plastic under, headers are pins, header equals pins. Headers are pins. This would be a square header because of the square profile of the pins. Square header, dual row, because there's 2 rows. 10 pins, because 1, 2, 3, 4, 5 times 2. So this is a breakaway square pin header, generally. And then this is, the pitch is the distance between the pins. That's 2.54 millimeters, or 0.1 of an inch, right? So unshrouded means that you can plug it in just about any way you can manage to get pins on this. Shrouded means that it's in a dark, evil society that shuns away from the typical laws of morality. No, wait, I mean, shrouded means it has like a shroud around it. It has a connector housing around it. And that'll keep you from plugging in anything you feel like into this. It's got, quote unquote, it's not enclosed. I wouldn't call that enclosed, but I guess you could kind of consider it enclosed. And so that shroud has a little arrow on it for marking of pin 1, the same thing that the cable header, the square header on the cable has to mark pin 1. Pin 1 is this red line. This is an IDC cable, and that's insulation displacement. What that means is that in this cable, there are a bunch of little pieces of metal that are like a cone shit. They've got like a wedge cut in them so that when that wire is pressed down into that wedge, it will displace the insulation and make an electrical connection to that wire. Now, these go pin 1, pin 2, pin 3, pin 4. And they do that because pin 1, 2, 3, and 4 are connected inside. So these two pins, basically this one connects here, and then this one connects here. And this is the standard for eurorack power. What they've done is they've made this symmetrical. So it's minus 12 on these two, plus 12 on these two volts. These are ground. If you plug this thing in upside down, you're putting 24 volts of energy into your system the wrong way. But anyway, that's sort of the technology. This is an old style of pins. Now, when I say keyed, that means there's what's called a keyway. And so this cut right here in the shroud is the keyway. This has a key, and a key is just a bump that keeps you from plugging this thing in upside down. Same with this. This is also a keyway, but it's very seldom used. That's also a keyway. This is a key, and it goes into the keyway on the shroud. And if you're my friends, the keyway goes into this part of the shroud, because that can happen too, because this thing can be deformed. And then it blows up your synthesizer and it ends up on the healing bench. So I'm not just explaining that specifically for you, Legoland. Some people don't understand this stuff and they want me to explain things in more simplistic terms, so that's what I'm doing. But yeah, the designer, Andrew at Nonlinear Circuits, did not design for a shroud, and you can see because the markings are so close to it anyway. So your red, they usually mark off where stripe goes. They call that stripe because the pin has a red stripe on it. So what they'll do is they'll put a marking on the board for negative 12 volts. And so that's where the stripe goes. And then for me, I always include what are called Schottky diodes. That's what this thing is here. Instead of 10 ohm resistors, because Nonlinear likes to put 10 ohm resistors in here in order to limit the amount of current that this thing can take. Instead of the 10 ohm resistors, what I do is I install Schottky diodes so that if this thing is plugged in backwards, the diodes will block any power from going in. I ask questions and hope everyone benefits from them. I lead you to a treasure I cannot obtain. Yeah, Schottkys are like a must for all of these synthesizer things because I've seen how they die. Things go boom when you plug it in backwards. Yeah, they do. Yes, they do. Okay, so the connectors that were intended for these boards are actually the Thonkicons that have these big pins on them. That's why the holes for them are so like vast. But if we can get in here quickly, we can drop enough solder that it'll bridge that connection. So that's the name of the game, is that we get in here and we drop just a whole bunch of what do you call it? Solder into the hole, and it bridges over to the pin and doesn't get into the connector at all. We don't want it to get into the connector, so we're not holding heat for a long time. Oh, I see. The resistors help protect your rack power supply itself if the module goes nuclear. I see. Well, I don't include them. I put in Schottky diodes just for a definitive wall between supply and module. They also get kind of hot. Okay, so the secret fourth reason that I put in Schottky diodes is because I've got a bin that's full of Schottky diodes of that particular size. I have an electronics bin that is just full to the brim with these Schottky diodes. So not only are they beneficial to put in, but they also use up some of the BS that I've got sitting in the shop. Well, yeah, all these theories about what will protect your power supply go out the window when, you know, you plug a car battery into it by accident, or whatever the hell my musician friends are doing with these fucking things to keep breaking them. They just keep breaking them. I don't know how they invent a new way to break them every time. You do what you can in terms of limiting current and putting, you know, overcurrent protection and voltage direction protection in these things. And the more clever you are, the more clever the ultimate destruction of your devices is going to be. They will invent a new idiot, and it'll be a better idiot than you are. So I don't mind that there's big holes in the solder. You know, I don't need to waste all of my solder to fill that hole. I don't need to have my holes filled that often. Every now and then it's fine. But yeah. Put it inside of a huge epoxy blob. I think the way to do it is to have somebody else use the synthesizer stuff through a proxy. I think that's the way to do it. Or just let them use the digital tools. Okay, so we've got everything installed. We got the PT2399s. I have absolutely no idea what any of the knobs do, so I'm gonna have to pull up a document in order to actually figure out what the hell is going on here. We can put this onto the oscilloscope and see if we can actually see anything new. No joke, we've destroyed our equipment with generators. That's true. Yeah, as much as you give protections to your friends, they're still going to go out into a field with a bunch of their friends, do a bunch of drugs, and then plug in their synthesizers for some reason to the dirtiest generator you've ever seen in your entire life. A little Honda suitcase that looks like somebody has actively flung shit on it. And then they'll drop all the power cables into a puddle. So, you know, it'll get the dirtiest power you've ever seen. All right, so nonlinear circuits. Let's open up the actual front panel of this thing so I know what I'm doing. And this should give us a whole bunch of delays. I gotta open this in another one. Copy, paste and go. You know exactly what's up. That was me. I was the one who did that. We made this 10 fire cannon thing. We used 100-gallon propane tanks as expansion chambers and big solenoid valves, and there were 10 of them. I made a little rack case, and we used MIDI in order to set off 10 valves that had torches at the top of them. And so, boof, big ball of fire. Problem with boof is that boof suddenly puts out your torch, so we needed a way to relight the torches. So we took a bunch of tasers, and we took out the taser elements, and so we had a little 9-volt trigger that would set off the taser and buzz, 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 buzz the taser. Well, how do most lighters work? Well, most lighters, you have a little pin, and you have, like, the torch, and it just sparks it, right? So I'm not gonna have 2 pins. So I connect one end of the taser up to the fire cannon body, and the other one to an insulated wire that goes all the way up to the front, to the tip of the torch. And it goes buzz, buzz, buzz. I said, okay, that's cool. Let's move on. So we moved on and we plugged it in with all our friends. And we had a MacBook that was connected to a DJ booth. And I said, let me see if we can relight one of these torches. Buzz, buzz, buzz. And the guy with the MacBook goes, my computer just turned off. What happened? And I went, hey, how grounded is this? How grounded did we connect this to ground? And my buddy, the mechanical engineer, goes, yeah, of course, I connected it to ground. All the metal is connected to ground. And I went, tasers are AC devices. There's no ground on it. We just tased my friend's laptop, MacBook. We're not gonna have music for the whole weekend if we don't. Luckily, Apple is good at designing electronics, and so while it did restart the computer, I think all of the protection elements in that, every single protection element in the power supply of that laptop benefited. I used them all. I used them all that day. So what I ended up using actually for the tasers in order to get high voltage all the way to the tips of these fire cannons was an automotive connector. So automotive connectors have all of these wonderful insulative elements to keep the outside world out and the inside world in. They're actually really, really good at that. So they have little rubber things with little nubblies on them. The electricity would have to dance around in order to get out. So those were perfect because they were nice and compact. They clicked in, they locked in. Good for production because we needed it to always work and never not work. And so having two wires up at the top of our torches that went buzz buzz between them, that worked perfectly fine. We were able to get that to work. So the fire cannons were a lot of fun. Those were quite a lot to put together, but yeah, they were extremely fun. I don't get a picture of the front panel. You cheeky bastard. All right, let's look up non-linear delay no more. Delay no mo. Images. Delay no mo. Oh, I guess we have a compact one. I just want a big picture. That's all I want. Okay, there we go. I used an ignition coil for something oddly similar once. An ignition coil might have been a good idea. We wanted that. I guess the reason that I did tasers was, first of all, because my friend bought a bunch of them before I could say anything, but also because we could send 9 volts over an XLR cable. We sent 12 volts and 9 volts over XLR cables to get to the individual cannons. So we could use cheap XLR cables without having to send uber high voltage. That would have been funny. Some hippie at a festival stumbles over one of her cables and tases themselves. But yeah, the MIDI thing was fun. It ended up being sold to some kids who did not know what they were doing with it. And so at one point they came to me like, help, we need it to be repaired. And I went, oh, Jesus Christ. It was an Arduino Pro Mini inside of the thing. And they said, yeah, so some of those pins sticking out of the top of the Arduino Pro Mini, we just gave that 12 volts and nothing happened. And I'm like, oh, you did what? You wait. Yeah, you know, because we know what we're doing with electronics. We put 12 volts into those pins. The Arduino that I was using, I think I have one example of it in here. I might have thrown it out. It was actually not a Pro Mini. I think it was just Pro. The Pro Mini has that programming interface on it. This one, here it is, has USB on it. So this is the Arduino Pro from back in the day. These used to be $50, and they allowed you to program things in Arduino. So I was able to make something, a circuit that took in MIDI and switched giant solenoids. Knowing the things I know today, I probably would have designed it completely differently, but it had a nice little port expander for the front panel that went to a bunch of these ice cube buttons that I had also illuminated with 2 LEDs. Pretty cool system. It looked really nice on a rack panel. Never really made its way into a rack of equipment, but it still looked good. But anyway, so this is the microcontroller, and that was sitting right there in the middle of a circuit that I produced and had a PCB made for, and those kids put 12 volts into the programming pins. Nothing you see here is compatible with 12 volts. Nothing you see here is compatible with 12 volts. 12 volts is way over voltage for this little guy. This thing can do 5 volts, but it will blow up with 12 volts. So those kids put 12 volts into it, and I said, oh. So I had to take the whole thing into my possession, and on stream, we actually fixed that. That was many, many years ago. That was early Stream Bother, but it was still a really cool project to do because I had to rip this thing out, get a new one for like $50. I think they're still 50 bucks. And then reprogram it from scratch. The problem is that entire weekend when we were first using the, because I lost the file server that had that code on it, so I had to just remake all of it. It wasn't too bad to reprogram, but yeah, the problem with that was that this used an attack that was over 0. So you don't hit any of the keys, the attack on all the keys at MIDI channel, or it was like keyboard row 0. You hit the button, it sends that message with an attack and a bunch of other parameters on it, and you get that from MIDI. My system looked at one of the parameters of it on channel 0, and everybody was yelling at me. It doesn't work, 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 it doesn't work. Your thing is messed up, your thing doesn't work, your thing is broken. And I said, you guys set it to channel 2 multiple different times. People just like mad at me. And it's like, bro, I do not want to work on work at the IT department that you work with. Holy shit. Like, man, people just had a chip. They just wanted to yell at somebody. All right, so module testing module. This thing barely fits because of that capacitor right next to it. Danger fun? Yeah, danger fun. Hey, you know, the more the project scares you a little bit, then it's worth doing. And boy, those fire cannons were scary. People would walk under them and we would set them off and people would like cower down because it was so hot. It wasn't like dangerous hot. They weren't damaging themselves by being around it, but just the latent heat. Yeah, the fire marshal hates us. Hate. Let me tell you something about hate. Fire marshals hated us. All right, so this is our initial power on. This is our initial power on. Initial power on is important. We're going to watch 12 volts to see if it goes and taps out. The power supply that I put in this thing is smart enough to not allow for shorts. It kind of cuts out intermittently. But when we power this thing on, we're looking for a big spike in current. We shouldn't see that. If we see the current just go boop, just up a little bit, that's perfect for us. So then the next thing we're looking for, because we have a thermal imager, we can look for any components that get too hot. Now they're going to look like they're on fire because this is an auto-ranging thermal imager, and it's auto-ranged for the hottest thing in its viewport, which is me. I'm hot. I am hot. I am the hottest thing. I'm super duper hot. Look at this. You can't do anything about this. I'm hot. But anyway, it auto ranges to my hotness. So my hotness is dictating about 98.6, although the latent radiative heat is a little different. And then the lowest temperature thing, I think the metal rails here are probably it, and that's why it's lower blue. By the way, this color palette, copyrighted. This belongs to Lepton. So if you see thermal imaging and it doesn't look like Predator and it looks like fire versus, I don't know, purple, you're looking at a Lepton device. You look hot on that infrared camera. I can assure you I'm nothing but cool. It makes my glasses look like sunglasses because they're plastic. Thin plastic will let infrared, long wave infrared through, but the glass of my glasses, the plastic of my glasses does not. It blocks heat. Same with glass. Okay, so we have all of these parameters, FPA, coarse, FA over B, I don't know what that means, fine, blah, 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 blah. None of this is adjustable, so I think we're just going to observe what this module does. We copyright everything. I know, it's a little weird that the color palette is copyright. So let's see if there's anything heating up. I can assure you the TL074 will heat up. This thing is always leading a tortured existence. The cool thing about eurorack, by the way, is that nothing in the eurorack system really does all that much work. You light up LED. Ow, that hit me in the forehead. That literally hit me in the forehead. I'm going to hit you guys in your 5 head. You guys have a 5 head. You're ugly. Okay, that almost went in my eye. The trajectory of those pins was up towards the camera. Some people have, there was a tutorial I saw once where they closed the flush cutters and they filled them with hot glue and then they cut down the cutting blade so that it released them again, so that you had hot glue sitting in your flush cutters that would deform when you cut metal with them. And so it would cut, but it wouldn't launch the pin into space. Sorry, I hope nobody's like on the edge of their seat for this. I'm dilly-dallying while doing this. Let's turn the module testing module on and see if we get any spikes in current. That's good. And then this thing powered up too because there's enough energy. Good, good. Okay. Yeah, let me guess. That's going to be the TL. Wait. Do we have a backwards capacitor? No. That's the... Oh, jeez. I thought the capacitor was lighting up, and I thought I was having flashbacks of when we blew up that one capacitor on air that went viral, but blowing up capacitors is fun and all, but it's also dangerous. So yeah, predictably, the TL-074 is heating up. It's not that hot. It's not that hot. It does look like it's going thermonuclear, but it's doing okay. I was grabbing tea, excited for launch. Oh, I need to get something to drink too. And then our echoey guys are heating up, the PT2399. I've never used this chip before, so I'm unfamiliar with it. I am unfamiliar with its game. The 7805, 78L05. I called this a TL-074, I'm sorry. Addendum, 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 correction, addendum, addendum, correction, 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 addendum. I should have this thing going off while I say that. Wait, let's do this. Oh, you know what? I didn't put the manual control on that. I'll have to put it back in at some point so that I have a button that does that. Anyway, I like FLIR. It has been so useful. OctoJ got me the FLIR system because he constantly seed my he done seed me. He did not do that. No, he saw me poking the chips to see if they're hot and like burning myself on things that were blown up. Like, oh, that's got really hot, ow. And so he's like, why are you doing that? And so he got me that whole system. We upgraded it a couple times, but this is a Lepton 3.5 in a Group Gets webcam module. Group Gets probably still has Leptons and webcam modules. The Lepton sensor's gone way down in price. If I were to do it all again, I'd get a higher resolution because now they're available because China cracked thermal imaging, and so America is no longer special in that regard. We used to kind of own the night, and we used to own thermal imaging, and now everybody has stolen that technology from us or licensed it from us or something, and it's annoying. It makes your stream fun. The irony of it is that OctoJ and I went through all that effort to get infrared imaging, and all that's doing is telling me which modules to poke first in order to burn my hand. Yeah, this is just above ambient. This is not bad. I want one of those thermal cameras that measures local peaks. We can have every pixel on that image, we do have a specific temperature of. This sensor is capable of doing that. Just the software that I'm using, whatever OBS pulls it in as a webcam, doesn't have that capability. And if we got into the STM32 programming a little bit more, I could maybe make an overlay that would give us specific temperatures in certain parts. But I haven't really deemed it necessary. We don't really need that functionality out of it. Sorry, I've got to readjust all my cameras because everything's loosening as I use it. All right, anyway, delay. So somewhere around here, there's going to be a control for the Vactrol. Which one of you is the Vactrol control? There it is. So yeah, this just lights up our LED and opens or closes the Vactrol. It looks like the dynamic range is like right here in the middle. It seems like, oh geez, there's a lot of distance on this thing that is not being used. Possibly mixing it with a CV would do something. I don't know what any of these controls are. Let's put a sine wave into it and see what we get out of the other end, and then we can try to make sense of what we're looking at. So this is nonlinear circuits, delay no more. Let me open up the, there's delay no more. Where's the picture of it? Do I have a saw wave? I don't know if I have a saw wave. I have a sine wave. That's what my module tester module has. So in CV and out. And then the scope. And we will go from channel 1 to channel 2. But actually, set this up a little different. I mean, I could use the frequency sweep to see what's going on, but let's just, you know what, let's just go into channel 2. So we're going to unfurl all of my scope cables here. Delay no more makes you see God. This is what I'm talking about. The lore and just all of the things that people like. The way modular synthesizer people talk about this stuff is kind of amazing. Good luck moving forward. Life has become meaningless. I have constructed, dear diary, I have constructed a delay no more module. I suspect we shall be making synthesis all through the night. Diary entry number 2. I have seen God. Here, let's do a powered mult so we can see what we're sending versus what we're listening to. Right now, this is just initial module testing. So I'm putting a sine wave absolutely nowhere. I'm sorry? Sine. Sine? Ah. No. There we are. Pretty slow. Audio sine wave. There we go. A little glitchy. All right. Sine wave. Into the module. And then channel 2 is our output. Burp. Holy shit. So it's doing this with just a sine wave. Whoa. Okay. Turn the filter off. That would be the audio thing. What is that one doing? This one's doing fine and coarse. What the actual fuck is going on? That looks like something's wrong. I want to take a look at my soldering. Because this is all the way at the top. Now we see something that somewhat resembles. So FBA, A over B. No. Holy. That's just going to sound crunchy. That's not going to sound like anything good. Then again, I am just putting in a sine wave. It's not like this is a sweep. And there's really nothing for me to adjust on this module either, but, oh, there we go. Oh. So, wet, dry. Apparently, wetness. Looks like a Lorenz attractor. I've not seen a picture of Lorenz anytime recently. I mean, yeah, he's pretty hot. Not looking too bad. Lorenz, although he's just dust right now. I don't know what that is. Okay. Any signs of delay actually working at all? No. No, so I think something's wrong with it. Because wet, dry should not only be influencing that. Like, that's doing nothing. And there it gets real dirty. Okay, well, something's going through the Vactrol. I have not seen the demo of this module. No, this is my first impressions. This is Lorenz Attractor Simulator on pure data in action. Huh. Yeah, let's take a look at the demo in just a sec here. Just want to see if I can glean anything from it. I was going to look at the circuit path next. Oh, I bet that's kind of cool. A lot of these nonlinear circuit stuff give you just enough rope to hang yourself with. So you got to be real careful with your adjustments on them. And then you can get some real unique stuff to kind of come out of the glitchiness. Plus, this isn't actually audio. I'm just giving it a sine wave. I just wanted to see some of the looping stuff going on. You should probably do that. This one's a complete monster. So you've hyped it to be. I'm looking for any errors in the audio path, though. Like anything that I might have soldered badly. All right, let's take a look. Take a look at the demo. This one's on, X might not allow me to. Oh, look at that. Yeah, that does look like that, doesn't it? That's actually, yeah, you're exactly right. If we let this get too wet, it becomes almost textbook Lorenz looking stuff. There it is. That's what the Lorenz stuff looks like. Wait, back a little bit. It's that moment when it switches over right here. Oh, nope, my scope decided that it wouldn't display any of that. Right there. Oh, that. Yeah. And then this is what Pajinki linked. And actually that Lorenz stuff is when you're trying to hit a voltage and you kind of wiggle around it. It's the noisiest delay chip ever produced. Great sound generator on its own. That's cool. The fact that you guys all know about this stuff. I mean, I guess because nonlinear is really popular, huh? I just look through the listing of circuit boards, and when you see it described, you're like, yeah, I'll put 20 bucks into that. Because it's like 2 PT2399 chips roped together in series, one with Vactral control and 4 different feedback paths. It's just a disaster. At that point, I'm already buying your circuit board. Like, you don't need to sell me anymore. You could have just put that at the beginning and I would have bought it. This is one of the most popular NSC modules, capable of a huge variety of sounds ranging from sweet to slow motion train wreck. Assembled modules, blah, 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 blah. Yeah. This is one of the most famous NLCs. I see. Well, it's good to get familiar with it then. I just happened to, the cool part about my part of the story on this one. My part about the story on this one. Wait, was I on the right? I was on this one. Yeah. My story about the module is that I got this in the mail and I went, well, there's going to be another one that I have to put aside for a week because I'm going to have to order parts. I went through my parts. And for the skull speaker, I was supposed to have a skull-shaped speaker that I could listen to this stuff with. And it was the first project I ever took to YouTube when I dual streamed. We tried to put the skull speaker together 3 times, and each time it failed for almost no reason. We were doing the easiest circuit that we could possibly construct to drive a speaker from Eurorack audio. And all of them failed. I was really disappointed in that. But anyway, I bought this kit because it had a couple of these ICs that actually drive speakers. And then sitting right over here in the corner, where's that? Was it in the corner? No, yeah, it is in the corner. Sitting over here in the corner is the humble PT2399, which is, in fact, CosmoQuest! Setting off CosmoQuestix's rating. Welcome in. How's it going? Yeah, this kit is crazy. It's just a bunch of common through-hole ICs that are for audio, and I ordered it for a completely different project. Turns out it had the chip that I needed to build the most famous nonlinear circuit. How's everybody doing? Welcome in. We're doing synthesizer stuff, so I've been sort of on a synthesizer bout for quite a while. We've been building eurorack synthesizers. Eurorack is just a way to get all of your modules in your synthesizer module. A synthesizer, in order to make music, in order to make audio that sounds synthesized, in order to make something that sounds like a piano, in order to make anything that it does drums, etc. There are certain topologies of modules that you go through. You create the audio, you amplify the audio, you filter the audio, delays, things like that. All of those are modules that have different topographies. If you go out to the store and buy a full synthesizer, sometimes you are married to whatever order of things they decided to go through. So Eurorack was created in order to make a walled garden where you can plug anything into anything and you're not necessarily going to blow everything up. You don't damage your hardware if you plug audio into a control voltage, that kind of thing. So that's what Eurorack is. And so my friend Julian, Zelikovic Music, has been pushing me for 20 years to get to know synthesizers. So we've been doing Eurorack. I've been doing a lot of it. We've been having a pretty good time of it, though. There's a lot of really cool stuff. And today we've got a bunch of Eurorack enthusiasts in the chat. And apparently there's like lore behind all of this stuff. There's like stories of people who have, done stuff in the past. It's crazy to come in on a hobby at this stage. But we're learning that the module that I built and that I'm testing right now is one of the most popular modules from Nonlinear Circuits. Nonlinear Circuits is an Australian bloke who creates just about one new module a month. I'm not sure if they still do that. Maybe they do. They might. But they got into synthesizers much in the same way I got into electronics, because they were already super involved in it, and they took college courses in order to bolster their knowledge, and now they're dangerous. So I've been getting into synthesizers because of Julian. I've not done a lot of stuff with analog audio until 2 years ago when I started getting into eurorack. And eurorack allows you to buy just the circuit board and everything else is on you. It's basically just like, good luck, asshole. Don't hurt yourself. And so I've learned about the power supplies, about control voltages, about musical stuff. And, you know, I've been in choir. I can read sheet music and stuff. This has been pretty crazy and pretty interesting and rewarding. One thing that I really want to do is decode some of the Easter eggs in Deltarune, some of the musical Easter eggs that are in Deltarune, because I've told you guys this, but it's one of my biggest crack theories is every time a piece of glass in that pixel art game, pixel art hell of a game, bullet hell game, every time a piece of glass breaks in the plot, it falls, and there's a pattern to all the little sprinkles that fall. And those patterns look a lot like the motifs in the game, and it seems like that's another layer of Easter egg that you could say, this piece of glass was broken then, this motif fell, this has to do with that. Like, I'm getting my red yarn out and all of my thumbtacks, and these walls will be covered in paper soon. Eurorack modules, individual, also cost as much as a decent digital synth. Yeah. Individual modules, and then you've got to get the case for it, and you've got to get the power supply for the case. So the thing about Eurorack is you can sit down and create something that's never been made before, and then you can reorder it to be something that is absolutely never should be made. And you're free to do that. That's the cool part about it. You don't see a ton of modular synthesizer in actual music production because getting things set to where they were before is difficult. You sometimes see it, and sometimes like a producer will pull like an individual music part in from a Eurorack setup, but generally it's like your walled garden to play around with sound. So I have been learning about it, and I have been building this stuff, and we have created the module that can blow up your face. This thing is the Nonlinear Circuits, what's it called again? Thingy-wingy. It's the Delay No More. So the PT2399 chip can do resonance and delays, and in the chaotic nature of nonlinear circuits, decided to plug one into the other one and create a horrible feedback loop. So the horrible, and this is totally in line with how nonlinear circuits does stuff. They create a new module like a month, and then they basically do the trace layout using something called Topor. Topor is a program what does as the crow flies trace layout. If you want to get into it, I have here something I designed with logical trace layouts going to logical locations. I've used curved traces in order to make nice, soft, clean, logical layouts. And if I had a synthesizer plugged in for this, I would have allowed there to be like nice instruments, dun 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 dun, and then it would go. This is don't mind the dog hair. This is Topor. Topor is a plugin for some CAD programs that lays out traces as the crow flies. It does not give a crap about 45-degree angles. It does not give a crap about soft turns or sharp edges. It simply gets to the pin that it needs to get to. The one circle pattern looks like the Laughing Man logo. That would be talking about this thing a little bit. I could do the little hat off of the side of it. I can post a Twitch clip of me doing a Delay No More solo with a Nintendo Wii nunchuck. Yeah, post that. I want to listen to that. I want to hear that. I'm not really going to be able to hear it very much because of the way my speakers, I have speakers that do desktop audio that are turned way down, and those go to the second channel, which does not publish the music. So you guys can hear it live, but you will not hear it when you won't hear it on the VOD. You're not going to be able to hear it. So the link will be in the chat for the VOD, not in the other thing. We've got an ad that's about to. We've got an ad break that's about to go off here. It says 2 minutes and 30 seconds, so we have time to listen to this. Okay. Oh, I like it. It hasn't started yet. Has it started? Oh. So it is just chopping that stuff up. Oh, that's cool. So what I'm seeing on the scope is totally appropriate for how this filter works. Yeah, so it's absolutely mangling the audio. So that makes sense. It's just Przynski found that it was exactly like a Lorentz. So whatever's happening in here is similar to what Przynski was. Where did that picture go? Did I close it? Probably close it because it's on X, open link, or Twitter. Whatever's happening to my sine wave is doing whatever this is doing. Go away. Which it like breaks up and then it turns it. Oh, damn it. Go away. A Lorentz equation VO2A, and it's doing all this stuff. Craziness. You also see that in control systems and stuff. It's pretty cool. All right. Very cool. Okay, so the behavior that I'm seeing is totally expected, I guess. Because we're coming in here. I mean, we could turn on the FFT just for fun. Let's see what the Fourier, what frequencies my scope could possibly see. Oops, turn back on channel 1. Turn off math. What the hell is that? Oh, our frequencies are weird. We want to have start and end, and we're going to start at 10 hertz. This is the audible range of frequencies. When they say DC to daylight, they're talking about what frequencies you can see, what frequencies you can hear on the electromagnetic spectrum. I'm going to go to 25 kilohertz. So 10 to 25 kilohertz. We'll use a Hamming window because I'm ham. And those are the ranges. So there's our fast Fourier transform for this particular sine wave. What frequency is this one? 65 hertz. So it's way up at the beginning of this. That's where we are. Oh, wait, we gotta wait. We got 3 minutes. What's up, Spiral Grooves? 3 minutes for an ad break. KiCad can do hallucinogenic traces. KiCad, yeah, but Topor is a specific, I believe, Russian program to do that kind of stuff. So we break down, and our frequency is starting to see other side bands. We're getting other noise in there. Oh God, oh God, oh God. It's all gone to shit. We should be seeing some higher frequency bands in there. And then there's our Lorenz. It's madness. Okay, I need more resolution on the scope so that this thing can see what's going on. Can't do it for like that. Okay, that's as much data as we can give it. Holy. Basically, the output of this filter, I'm going to want to put into something that'll stabilize it into the audio range because we're getting a lot of ultrasonic reverberations in here. Holy. Oh, this is going to take some learning. Father's going to have to do a little bit of learning. So, Okay, not doing anything, not doing anything. So there's not much that we can do on this one. There's no adjustments here. I could try putting my triangle wave control voltage into it and see what it does, see if it responds. It's hard to test stuff like this. I guess I just need to get the rest of my synthesizer plugged in. I've unplugged everything from the synth, and I've sort of put everything to the side because there's a couple modules that need tuning. What is that going to control? That is a very slow triangle wave. Yeah, there's the triangle wave. So it's just like killing my audio with that control voltage. Just everybody's normal. And then, oh no, that just keeps it. Okay. I wonder how this would respond to a frequency sweep. Really not much that I can do. I'd have to plug this into the rest of the setup in order to hear it play around with normal audio. Well, looks like we're back in just a second here. Boom, that's the expiration of the ad break. Hello, everybody. Yeah, so we looked at a sample from DJ Corn Sweat. Looks like a cool stream over there. Everybody should go check out DJ Corn Sweat. But their Delay No More module was used with a Wii Nunchuck in order to create some kind of a solo, I guess. But it looks like this thing is just here for pure evil. Whatever it's doing to my sine wave probably shouldn't be recorded on camera because it's just awful. And I can tell it to stop, and it'll just go right back to being a normal sine wave. But yeah, we're introducing all kinds of this like nonsense that's going to create sort of kshing noises in the audio. Not much, I'm not able to tell much of what else it's doing. It seems as though our Vactrol does work. I've got a slow triangle wave going into the Vactrol through the control voltage, and it appears as if it really does respond to the entire range of that triangle wave. And much in the same philosophy as the rest of nonlinear circuits, this thing is chaos wrapped in a potentiometer. If we allow it to be. It appears as though it's not returning us totally to normal. Yeah, there's just like a buildup of extra noise around my circuit as that goes up and down. So I think this is more of a bother needs to learn how the module responds rather than a bother needs to tune the module, because there really is not much I can do other than just inspecting all of my solder and making sure that everything is soldered in properly. And all the values of the stuff, I believe, are what was called for in the addendums and the notes and stuff. And this is all 0805 sized. I put in 0603s, but it's 0805 sized. So the soldering really does not leave anything to be desired. It's that 0603 stuff that's really the insidious, difficult stuff. The only thing I'd have to do is space out the holes a little bit on the front panel. They're a little bit too narrow for the thonks, but it's not a showstopper, and I probably won't notice very much, but like that's not good. that needs a little correction. Oof. Roblox oof.jpg. I could just quickly fix that. Just push the board in. Although in the same vein as nonlinear circuits, I mean, what would Andrew, who's viewing us from up there and is on his cloud in heaven, he's still alive. He's just in Australia, but sleeping in his bed probably right now. What would he want us to do? And the answer to that is the most chaos. So whatever's the most chaotic is what I should do. So leaving these things sticking out, probably fine. All right. I'm gonna call that done. All I need to do is the front panel, but that's a lot of knifing that needs to be done. I was wondering about this with a frequency sweep. I wanted to take a look at what some of this stuff is doing, like the clocks and stuff on the digital filter simulator, because that's the one that fascinates me the most. The digital filter simulator is another nonlinear circuits, and I've got the schematic open right here. I can tell you what this thing is doing. What we're doing is we're inputting a eurorack level signal. Let's get the scope out of here for right now. So that signal comes into a 100K 100K amplifier, and I really wish that he would lay out his circuits in a way that engineers typically do, but at least, yeah, I don't know if he follows my no four-way junction rule. When I draw a schematic, I will never draw a four-way junction. You note junctions between wires by putting a dot over it, and if you forget to put a dot on your wire, it looks like this. And so if you never do a four-way junction, you see this and you know that you forgot a dot. If you ever do four-way junctions, then you'll get something like this, and you'll go, I wonder if that was connected. So no four-way junctions, none. Do not do them. If you have more junctions, you put another three-way in there. It's kind of like, well, it's like playing factory games where you have a splitter that only goes, you only have T-splitters. It's much better for drawing schematics and the understanding of schematics if you never, ever, ever acknowledge the existence of the four-way. You can do that little like swoop-de-hoop jump, but what if you forget to do it? That's always the question. What if I forget? And you will forget. So yeah, don't do it. Take my advice. Anyway, three-way junctions only. What this filter is doing, what in the hell's going on here? I don't know what that's doing. Oh, I see. This is adjusting the thresholds. Oh, I thought it was just purely done with this. I guess we're amplifying to a degree. I don't know, man. Hold on. Oh, that's adjusting your output levels for that. I see. Oh, that can create some chaos. So what we're doing here is we are adjusting the output level of our 1, 2, 3, and 4 levels. Those 1, 2, 3, 4 levels are our 4-bit audio processing. So we have 4 of these CD4015 flip-floppy kind of things, right? What this will do here, CD4015, let me just double check. CD4015, I want the data sheet, not the AI bullshit. 4-bit shift register. Serial in, parallel out, common use, giving more pins for a microcontroller such as an Arduino. So we are shift registering. So for each count of the clock, we are moving a bit to the next location. This is like the first semblances of memory in CMOS logic circuits. So if you send a 1 in and the data clocks over, your 1 will be flipped to the output. Then another clock comes in, your 1 gets flipped to the next one, and the next one, and the next one, and the next one, right? That's how that works. So we're shift registering our different voltage levels back into a digital to analog. So analog to digital happens in this ladder here, this 10K ohm resistor, followed by the next 10K ohm resistor, followed by the next and the next and the next, does essentially what a VU meter does. LEDs light up for each different voltage level as you overcome. Oh, that's an overload indicator? Oh, because that's all the way at the top, I see. So there's an overload LED at the very top of the range, and then each of these diodes is a voltage threshold that you set using these potentiometers. So once you've gotten over the diode, you've then created a 1 or a 0 on your lines here that will flip-flop over with a clock. Where's the clock coming from? Well, the clock comes from your waveform over here. You can input a separate clock, and this will disconnect and connect to your amplifier up here. But the 1s and the 0s for the clock are over here on this 100 kilo ohm resistor after a diode. So the clock is being created by the waveform moving around. As that clock is being sort of vibrated, your signal coming in here, I guess also dictates the output, where for some reason we're getting this off of the feedback resistor. But Once it comes out of the other end and gets shifted from Q, A, B, C, and D, it will go into different value resistors and get mixed in to your output. Pretty cool stuff, huh? So people remember all these parts. Are there not as many parts as I think? Or did you just learn them? You learn them as you go. The more commonly used things, like when I talk about like a TL074, the TL074 is your most what's called jelly bean part. Jelly bean parts are parts that you'll use often. So your 1N4148 diode is a typical, let's throw that into your diodes and take a look. Shift registers broke my brain when I first learned about them, but now I find it a beautiful process. I have a little like ruler that has like LEDs on it for operating like a flip-flop, and it still breaks my brain. I've learned a lot of stuff about that like in school and out, and it's very confusing stuff. But yeah, you get to know all these parts. You get to know sort of the common part numbers. And if you're doing eurorack stuff, everybody's copying everybody else. So like an LM13700, I know is a controllable, voltage controllable fader, like that you can put in and have it's just one of those things. There's only passive components in semiconductor. Yeah, there's only so many of them. There are a lot of them, and you kind of get to know what some do and what others do. Like the 7400 series, engineers used to know almost the entire catalog of 7400 series logic chips. Some kid built out of Lego how shift registers work, and it's great visual. That sounds interesting. Yeah, so you know, there's if you're building stuff like this, you're not necessarily looking for, like when we open up consumer devices, we find the most economical parts, and those are not your jelly bean parts. When we open up Eurorack stuff, we're finding a lot of jelly bean parts because they're not nickel and diming to the degree that sort of a full production electronics setup might do. So then we get to know those parts, and we get to know the CD4015 and all these other different TL074s and your 555s and your 556s. So that's what I understand is going on, although I don't know what 1, 2, 3, 4 are doing here. I don't know what these are necessarily doing. I'm a little confused. This is a feedback resistor between two legs of a unity gain inverting amplifier. So our audio signal comes in here and it reaches 100K, 100K. That is a that's an inverting unity gain. So that's 100 over 100 is, well, it's 100,000 over 100,000, which is 1. Better or worse parts, depending on what the intent is, yeah. I'm gonna get the hiccups if I keep talking without having something to drink. But then we've got a voltage divider, 150, 100, 100, 100, 100, 100, 100, but it's got an adjustment on it. Original, R-4, R-3, R-2, and R-1, and those go back into the mix. Unity gain. This one's like half. This one's a quarter. Yeah. So each of these are voltage levels, and when you get 4 of the voltage levels in the same thing, I guess they're going to feed off of one another. From levels D1, 2, 3, and 4, feeding back into the, oh man, that's a lot of stuff. That's a lot. I mean, the theory of operation for this thing is pretty complicated, but essentially that's what I'm seeing, but I don't know what our adjustments are on either end. And there certainly aren't 8 potentiometers on this thing, are there? Oh yeah, there are. Yeah, there are. Wait a minute, there's plenty of, okay. So I want to see what this thing does with the frequency sweep. Let's get the function generator on this. And we'll get a long BNC cable because the function generator uses BNC. It does not use eurorack. Although I do have an adapter that I could use with this thing. Wait a minute. Yeah, I don't need the BNC. I could do it this way. Hold on a sec. We're smarter than this. Give me this BNC into thingy-wingy into the splitter, and then we can put our function here, We've got our sine wave on the other one into the powered multi. And then we're monitoring it, so we don't need the Y junction over here, which causes all kinds of problems with me hitting the screen and it disconnecting. See, I just accidentally activated channel 4, trying to get my BNC back. I guess a little BNC extender would be nice. Oh, wouldn't that be nice? Get a drink? No, I'm too excited about working on this stuff. Having a lot of fun. Now I don't... Whoa, what did I just open? Channel 1 plus channel 2. No, we don't need that. That would actually be pretty good for observing waveforms, but... Oh, are these not centered? There we go. And channel 2, centered. Okay, they should be on top of each other, unless there's slightly different potentials on them. Power this thing up, and it should boot us back into where we were. Yeah, there we go. We got a nice frequency sweep going. Oops. 6 volts max. What is channel 1 doing? Yeah, 6 volts max. So this is doing 10 hertz all the way up to, I think, 30. Why are we on? Oh yeah, we're on. So our channel 2 has the FFT going. So if we were to view that and do the FFT of that, we would see a little traveling spike. So if I actually plug our output into here, so there we go. We just see, this is what the frequency sweep looks like. There's a lot of side bands on it, but it's just coming through here and sweeping our entire range. Probably could slow it down a little bit with the resolution. There's so much data going into this right now that it's using up my memory. I could probably assign this with less memory and it would look a little bit better and everybody would be able to catch up. But okay, so now into the digital filter output, which I need a picture of it. Non-linear circuits, digital filter sim. We have looked at this, but we only looked at it with a static wave going in, and I kind of want to see what the waveform coming out of it looks like. Okay, so range feedback output, in 1, in 2, out 1, out 2, clock, and then the control voltage for the range. Range is here, feedback for all the channels, so that's what that was. And then the output is on the last one. Okay, cool. We can handle that. We can handle that. So output, there's a squirrel outside and I hear it and it's chattering. Wait, where's channel 2? I plugged channel 1 in. Oh, I didn't even plug in channel 2. Oh no, okay, yeah, I recently unplugged it. It's no longer doing its thing. Okay, cool. So output, you know, I should probably also plug this thing into power. Red. Nice dirty power insert. So peak is there, range is here, turn the range down, turn the range up, nothing changes. This down, this up, nothing changes. And then output down to output up, nothing changes. So in 1 and in 2. So it's range clock in 1. Oh no, that's not, no, we want output. Output is down here. Output down here. Input, our sweep. Input 1, turn the output up, turn the output down. I'm not getting nothing. Double check. Did I plug it in upside down? No, it says red. And we're getting a no huge current draw. Check our other output. Fascinating. Turn all the feedback down. What are the next ones? Those are output. Turn all the outputs up. Turn all the outputs down. Turn all the outputs back up. Feedback up, feedback down, range up, range down. Nothing. Okay. So we got to take a look at the soldering now, because seems to me like a piece of the audio path is not really going through. Check to see if CV is doing anything. Give it a nice slow triangle wave into the CV for range, although we don't really have any confirmation of what is going on there. Whoa. I think that's feedback through my finger. Yeah, that is. Whatever the hell range is doing. Certainly the potentiometer isn't doing anything with that. Okay, so I think we've got some connections here that aren't being made. Oh, no, range. Oh, that's clock. Hold on. Input. There we go. Let's get the CV out of there. Try adjusting it with this. Okay, it seems like something is still wrong with it. Because that's not a good... Whatever the hell is happening there. Seems like there's like a changeover. Whoa! As usual, this is as dirty as they get. This thing is filthy dirty. Oh! What the hell is happening there? Take these all to the middle. Whoa, something crazy is happening in the middle there. But that's with the control voltage. If I don't have the control voltage... Oh no, that's not with the control voltage. That's just with the frequency sweep that's happening. It's like cutting into nothing too early. There was something on the line there. Okay, something is like turbo messed up with this. Let's get this all out of here. If you guys can't hear the sweep, I'll leave it out. But this interferes with my equipment sometimes. Okay. So this is what we've been doing with the... I'm going to just turn that off so we don't have any interference. This is what I've been doing with these things, is when I find a module that doesn't appear to work right, we just basically go over all the solder very carefully. That's usually where the failures are in this. And we could trace out some of the stuff as it's happening because we have the schematic. So we're just going to take a look at the chips first, but also all of these various components, just to make sure that everybody's soldered. You know, when you're putting 10,000 10K resistors down, sometimes you forget to solder a leg. Like that looked like it was almost unclean, like the solder on it had not flowed properly over everything. And in order to do these corrections, we are using the larger soldering iron tip. You don't need a super duper tiny precise soldering iron in order to do work like this. I mean, it's nice, but it's better to have the big brutish soldering iron so that you can very quickly flow over the solder on your entire chip. Also, with these chip resistors, sometimes you can nudge them into place by heating both pads at once from the big iron. So this looks a little bit like it might be a cold weld, and you got to really just like look up pictures of cold weld solder pins on the internet, and the pictures are nice because the pictures show you exactly what it looks like. Time and time again, if you see a little ridge in the bottom of the little foot of the pin, there might be a cold solder joint there. So doing a little too much solder is what I'm doing right now. I'm being very careful with it to not get too much. But if you see like the professionally soldered stuff, there will be way less solder than what's here. I'm doing this because it's peace of mind and I know that it's connected. Also, it's not a big deal if there's too much solder. Man, we just hemorrhaged a lot of users. What happened? Twitch messing up again? Or everybody just got bored of my bullshit. So Bother just explained something and it was completely wrong. I have never heard something explained so confidently incorrectly in my entire life. So we're really supposed to be heating pads, not pins. You heat the pad, I guess you heat the pin too, and you apply the solder to the pad so that it flows over and it creates not a bubble, but this nice kind of like smooth, what looks like pulling your hand out of water and the water's like flowing around it and stuck to your hand. And that's sort of the look we're looking for. And we're also looking to see if there's solder bridging between any of these pins. These are all SOIC size. When you get lower than the SOIC size, that's when you start to see some dodgy things with the pins. Now this looks like it's probably fine. It looks kind of like it's a dry top of the little foot, so I'm just going to apply a little bit extra on it. Just a little bit extra, just in case. I really don't think that any of these are not soldered. Well, maybe a couple of them are suspicious. Auspicious. What in the fuck was... It was like an alien. Ugh. That was plastic from the tapered ream shriveling up as the iron got close to it. But man, it looked like a scary alien from a movie. These look fine. My soldering's fine. It's perfect. It took me a lot of work when I got into the professional world to take criticism. I don't know what was up with me, but on writing documents, the criticism that I would take, it was tough to learn how to shut the hell up and just roll with it, right? I didn't do that. It wasn't me. I didn't make the mistake. No, you gotta own stuff. Giving criticism is its own psychology, though, on how to keep somebody receptive. Basically, you layer it in a bunch of praise, and the praise has to be genuine. You must be able to find the good in this world. That was not the good in this world. That was a that was a frustrating thing, where the solder goes to the iron and not on the pad itself. These look fine. I have no criticisms at all. To be fair, some people are just bad at giving criticism in a way where it doesn't sound like they're tearing you down. I call that I think that's the tough thing to learn how to do, is to be criticized in a way that's not tearing somebody apart. A lot of the internet has forgotten how to do that with the movies and films and stuff. I think one of the best Red Letter Media episodes is when Len Kabaczynski, of the same state that I reside, although he's in the western part of the state, was on with the boys, and he said, you guys need to say something positive about these movies, and he made them lay praise on the movie for things that they thought it got right, and they were able to do it, but it's hard to do. It's hard to do. It was good to see him making them do that, instead of just being entirely negative, which is the internet. That's the modern state of the internet. I don't see any problems with this board. Wait, what's that? That's a problem. Although it's probably not. It does look like it might be one. No, that doesn't look like I soldered it. Oh, no, I did. Now there's plenty of solder on it. The camera and the lighting are not displaying properly, but it does look like, let's check down this other side. I do not see any errors. Everything looks perfect. It's perfect. Yeah, it's like the only thing is I could see a little bit more solder going up to the top of the chips, but it kind of does. I mean, it's there. There's solder there. They're definitely connected. So overall, I think we're just looking at the operation of the filter, and it's possible that it's on me for not really knowing where the adjustments need to be, or how even to see the adjustments. Maybe if I fed it like the clock has to be really fast, though, to get this whole thing doing its thing. Or setting the clock as a function of the waveform that comes in. I think that's a little crazy. I don't know what that's supposed to be doing. Does that have solder on it? It kind of does. There it goes. These look fine. No errors in any of it. No, all of it looks fine. course, I gotta order from some other place than Modular Addicts, because Modular Addicts seems to have a few too many of these white solder mask boards. I dislike them very strongly because it's difficult to see traces. Green over anything, red looks cool, blue looks cool. Yellow is quite nice too because of the contrast between the circuit board substrate and the traces. Yellow makes a very pleasing circuit board. Black and white are terrible. White's only good for lighting because you know light will bounce off of the white. Anything else is a bonus. The After Dark service, where the traces are still like copper color, and then the substrate is like a matte black, and the solder mask is just this clear coat over it. That looks really good. I wish it wasn't so expensive. Anything else is a bonus, but I mean, it's really blue, red, yellow, and then green are the better ones, but not in that order. Actually, in reverse order. Blue and red are the same to me. They look exactly the same, but yellow and then green is probably the best for seeing the traces. And you know, it's nice to have a cool looking board. You get all these graphics cards with all these crazy looking... Well, they don't do that anymore because they cover the whole graphics card and stuff. They got plastic all over it now. It used to be you buy a graphics card and it was just a circuit board. Old man yells at cloud. I need to put that in here so I can pop it up with the Stream Deck so that while I'm rambling like this, maybe I could turn it into a channel points thing so you guys can activate Old Man Yells at Cloud. That's actually a really good one. Let's make that right now. Let's make that right now. Chat message, raids, sub or gift, points redeem. So we'll take... Well, first off, I'm going to take my scene selector turner oner thingy from this. So that's all this. From off and on. Set a duration. Variable delay time. Hold on one sec. Oh, I need something on, something off filter. So that's actually going to be the willow trigger. That's exactly the willow trigger. Okay, so let's take the willow trigger. I need to pack these into their own little system boxes because that would be a lot easier for me to cut and paste. To be fair, some people are just... Oh, I already read that. Sorry. That was a first-time chat. Thank you for the chat. I appreciate it because we can talk about stuff. Chat message contains willow. Contains willow. Something on, something off, set scene. Oh, so I don't need to... Scene item enabled. Oh, I see. Yeah, the scene item ID is something that I need to get for a lot of these. Because if I change anything in my OBS, that number will change. And that's what this giant flow does. Ugh. Okay, so if we're doing... channel point over here, and we're not doing this set scene, we're doing this set scene. Oh, where are we? No. Lost my place. Big brain moment. And contains old. Old man. Contains old. Then message payload. Or no, we're gonna set... Okay, so this is gone. And we're taking the willow message. That's switch 3. That's a different thing. So we're looking for chat willow. Oh no, the willow one was fixed. We're looking for the one that looks up its own thing. Yeah, that's this one. Okay. So we take this. Whole nonsense, copy it, and we're going to put that where we have our bits redeem, and that goes here, way over here. Uh-oh, no, ah! It locked itself in when I tried to scroll. It goes way over here, because it's just a sequence of events. I guess you do these in kind of a cascade for Node-RED. Doink. Okay, and then it's going to be a new one, so I'll bring that in a minute. First, we do old man, and then we do a little timer. So set, but it's toggling, so it'd just be a toggle delay. Yeah, 5 seconds is probably fine. So we'd have, how do I do two things into one? It's like that. Okay, maybe it just goes to the one below it. All right, get out of here. I gotta clean up all these flows, man. I think I need to have subflows for some of these. I need to make a node that does this. So we would have, thing goes into here, this goes back in to untrigger whatever it just triggered. So this goes in there, and then it also goes below it. And I guess I'm just going to pull this all the way over here. So like that. That's how we toggle on and off with a delay. And then what we're looking for is frameless overlay, and then I need to find Old Man Yells at Cloud. And I would like to find just Abe Simpson. There we go. What do you, don't redirect me? No, 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 anything but that. Okay, it's actually not redirecting me. Cool. I think I'm just going to grab that thumbnail and let's see if I can put it into the frame. I got to go into studio mode 1 sec. And then frameless overlay. Does OBS support drag and drop? Yes. No. Where'd it go? What? What? Why did it disappear? Did it something to do with PNG? Like, why does it vanish? Properties. Apply alpha in linear space? No, none of those did it. It's not covered over by something. It's the top thing in the scene. Is it somewhere that I can't see? Open source projector, add source, scale filtering, blending mode, order. It's at the top. Transform. Center to screen. It just disappeared out of OBS. What is that? Well, I'll probably try to put it in a weird place. All right, so I'm going to delete that. Weird. I'll just place Abe on the desktop then. I'll have to put a Steam Deck control on that too eventually, but right now it's just fine on the way it is. So I'm going to add that as a source. That's weird. OBS, like when you drag and drop a PNG in, it shows it for just 1 second and then it's like gone. So add an image, now create a new, and that one's called old. We'll just call it old. And then browse to desktop, find Abe, there he is. Where did that go? It's in there. I can't see it. Oh, it's way off in the corner. Okay, so it's at least visible though. Yeah, so now I can pull this in. There we go, just right over me. And then we deactivate it, and it's called old, and it's in frameless overlay. So get out of studio mode here, make my window back to where it goes. Now what I can do, let's do, where am I? I'm going to Node Red, and frameless overlay, source name, old. Done. Now, if I put that on a toggle, let's just test that real quick. So I'll just grab a toggle from anywhere. Grab a, there we go. Go to this convoluted thing. Deploy, confirm, boop, didn't work. Cool. Wait, I think it takes a minute. Node-RED is a way to automate stuff. It's like Java flows. So when something in OBS is, or something in Twitch, the Twitch API is triggered, I have it go into all of these flows that peel out either chat messages, raids, subs or gift subs, points redeems. It's why I have all these lights that turn on and off around me. It has gotten complicated, but it's actually fairly simple at its premise. Node-RED and home automation are often used together in order to do a lot of sort of automation around your smart house stuff. But I use it for automating things in Twitch. So I was going to make a channel points redeem where you guys say I'm an old man and Abe Simpson pops up on the screen. But unfortunately, it appears as though it is not working. Oh, because the message doesn't contain old. That's right. Okay, so what I wanted was toggle to here because my toggle doesn't contain old. So if I deploy this again, what'll happen is if I push this, Abe Simpson comes up, and then I push it again and it goes away. So that works. So now what we need is for me to go into Twitch and enable the channel points redeem. Yeah, Node-RED is a way to make these flows that are essentially Java flows. See, I don't have a channel shout-out thing that activates. We're going to add more functionality to this later, but for right now, you can see I'm kind of like shoving things in here. I probably should have new tabs for all this stuff. So now that I've got that, we have a 5-second Abe Simpson trigger that can be set off by channel points. I need to go into my stream manager here, which is kind of dangerous to do because that's where you guys could accidentally see my stream key. So which is points redeemed? Not monetization. Moderation. Settings, stream channel, streamer survey. No, that's not the one I want to show. Creator badge drops, power ups, and channel points. There we go. Customize channel point display, manage power ups and channel points. Oh God, I don't care. Custom reward, give your reward a name. Old father is complaining like an old. Nobody has to do text. Does that mean? Well, I think the fart filter, yeah, it's fart or old, and so the reward name is old. So if it contains old, so I could probably put old man after it, but bother is complaining like an old. And the icon, where do I edit that? Background, I don't know, gray. I don't have a good image for this. Although cost would be 200. It's just an on-screen effect. Cooldown time. 3 minutes. My rants aren't longer than 3 minutes, so well, maybe 1 minute. Otherwise, you guys are going to hammer it. Redemptions per stream, redemption users per stream now. Per user per stream. I could see somebody hammering away at it, but if I give it 1 minute in between redeems, that gives you time to cool off, and so they're not going to be bouncing on the button. There's a pre-made icon gallery, but they make you split it off into different resolutions. I can't just throw one in there. None of these represent being an old man. Maybe, nah. I mean, 500 is a little steep for it, but skull and crossbones. Wait, they make you download it? The fuck? That's what I was thinking of using, but it makes you resize it into 3 different sizes. It does say drag and drop your image here. I wonder if they have their auto resizer. They do have an auto resizer on the emotes, but I don't know if they have it for this. Let's just see. Nope. Really? You're not going to give me a resizer for that? Isn't that, yeah, that's obnoxious. I'm not going to spend the time to do that. No. Stupid. We have that ghost one, but then I got to do all that work to put it in there. Fine. Here's the downloads folder. Ugh, this sucks. Twitch, how could you not plug that system into this? This looks like a synthesizer module because it's just called Skull, and I've got clouds, and I got it's like all the other stuff here. Weird. Extract to Skull. Ugh. I mean, I can do this with GIMP, but it's going to take like a year. Image required. Really? Create. All right, there you go. You guys can call me an old man when I'm ranting about stuff. The description is bother isn't old. All right, that was a bunch of hullabaloo. But that's how quickly I can spin off Node-RED stuff. We got an ad starting in a minute here. That's how quickly I can spin off interactivity stuff on the stream. So, you know, we come up with it. We can make a Node-RED flow pretty quickly. Did that pop up? Did that work? I haven't see, I have infinite redeems, so I'm just going to redeem it for myself. Father is complaining like an old. Wait, what the hell? What? Why did I not? It did, it worked. Cool. Do we have to wait a minute for it? Yeah, we do. 13 seconds. Oh, geez. I might take away the minute timer. I might take that off. It would be a 5 second because it pops it up for 5 seconds. Something went wrong. Please try again later. Now use AI to animate it. No, because that'll look like dog shit. Oh, there we go. That's perfect. All right, so I need to change the timer on that. That was with the community stuff here, power-ups and channel points. Boy, there's a lot of shit to wade through. Your own custom redemption alerts. Yes, I know. I have my own custom redemption. Ah! Ad break! Jump scare. It does minutes, hours, and days, so there's no delay, I guess. But I just... Wait, what? Oh, so I just take off the cooldown. Oh, I see, okay. I wonder if I could put in 0.5 minute and that would work. Let's try that. I want to try 0.5 minute because it has a 5-second timer on it, so it'd really be like 0.1 minute. No, that's less than that. What is that? Divided by 60? I don't know. Never mind. Whatever. I'm not going to do it. Just leave it alone. I'm too lazy. So there's really no going over any of this. It looks like everything is perfectly soldered. 100% perfectly soldered. I guess I do need to look at the board below. So let's look at the board below and see if there's anything that looks like it needs to be just touched with a wee bit of solder. That's what sideways inspection, the 45-degree angle inspection is all about, is looking to see that all your stuff has solder on it. And that's it. That's all we're doing. Making sure that I haven't neglected soldering anything. Because when you build these, you go get a bottle of soda, you come back, you drink the soda, you do a little bit of soldering, you start getting the jitters because of all the caffeine in the soda, and you go walk the dog and you come back and you don't remember what you were doing. Nah, looks like everybody's here. There's really nothing to speak of, and there's so much room on this front side. There are no components here to share. Everybody's soldered in nicely, and they're all the correct values from what I understand. Mercifully, this one is semi-digital, and it's all the same circuit over and over again, so they're mostly 100 kilo ohm pots. So, I mean, I suppose this thing is correctly built. We got 10 seconds before the ad break is over. I have a broken down GameCube sitting on my table that I was working on. It's been like that for the past month, and I can't remember where all the screws go. I should have taken photos. GameCube is popular enough that you should be able to go out and get, you know, oh, there it is. Ad break's over. You should be able to look up pictures. There's probably like an iFixit tutorial on taking apart the GameCube. You go, oh, that's that screw. That's that screw. Sometimes you have to have like the logic on your side and go, if I were putting this together, if I were Joe Nintendron and I was designing this board, this thing weighs a bunch, so they're going to want big plastic screws on this. This thing can't be seen, so the really crappy looking screws go here, and this is in plain view of the consumer, so a security screw goes here. That's the kind of logic that you have to bring to the table in order to reassemble something properly. But there's a lot of twists and turns, but the GameCube is popular enough that you can either open a YouTube video, or both, or probably just an iFixit guide to take a look at where all the stuff goes. You're actually in good hands for that. Yeah. You should get on that so you don't lose the parts. That's the big thing about leaving something apart, is that the parts get more apart as time goes on. What's my blood glucose level? What? Oh, that only works in this scene. Okay, coming back down. I for the first time in like I think a month, I had McDonald's for lunch, and there's a lot of carbs with that. Give a lot of insulin, but this glucose level is going to start really crashing down now. I think I've been losing weight. My belt appears to be strained a little bit, but I have not been taking my weight. I have been too reluctant to get on the scale, so I need to do that. I need to just get on the scale, get over myself and get on the thing and see where we're at. The last time I checked, I was maintaining at a slightly lower weight than when I started. but it's not enough. I should be seeing more progress. So I will be working on that in the near future. Not eating. I've been not eating. It's just it's taken a little bit to kind of take hold. This is our signal sweep. We've got our signal sweep is on, although it's looking a little weird. Why does it look weird? Why does that look like that? Oh, because is that just noise in the system? No, that should be... Oh, this isn't on. Oh, we haven't turned this on yet. That's just what's getting out. So red stripe goes here. All right. And then power on. I want to see what that clock pin is doing. So I'm actually going to plug in channel 3, which is purple. We got the purple channel going on there. And I'm going to get a probe. Give me probe. That's me getting abducted by the aliens. Let's plug that in over here. This is when it's an advantage to have your scope up on its own monitor. If you've got the scope on a separate monitor, then people can walk behind you and see all this cool stuff going on and go, oh my God, he's so smart. Okay, resumed way in. Why did the FFT change when we did that? Oh, I guess because it's getting less data per thingy. All right, I need a ground. I guess I can get it from... Those look isolated. The legs of the pots will be a good pinchy point for everything. I'm gonna back you guys out even more just so that in the vertical video we get more information about what Bother is doing. Yeah, YouTube, and I was saying iFixit and stuff. So the LM39, we had that open just a second ago, but I think we have pinouts on the schematic diagram too, so I'm going to open that up in another window. Where are you at? Oh God, it's like way over here. Delay no mo. No, that's not, we want digital filter simulator, and I'm interested in the clock pin, and so that's pin 7 of these ICs. I should also probably play lip service to making sure that my ICs are in the right direction, which I think they are. 4016, 1, 2, 3, 4, 5, 6, pin 7. No clock. Well, no output either. We've got an input going into the thing, but we don't really have any output going on. But we're not making a clock, are we? 1, 2, 3, 4, 5, 6, 7. There we should be seeing a clock. Here we should be seeing a clock. Okay. So, and this is the 4015. Yeah, it is. Okay. So, why are we not... Oh, because I'm not giving us any inputs. I forgot to plug it in. Why are you looking at me from over there? Okay. Plug it in. So, let's see. This is our sweep. That goes into input. That's an output. That's a CV. Wait, hold on. Oh, no, it's CV clock. This is input. Okay. And then let's set it so that some kind of nonsense is happening here. Give me nonsense. Nonsense. We had it so that it was in the middle of doing nonsense. And I was pretty sure that this thing was broken, but it seems, as it turns out, it is not quite broken. It was actually working. I don't know why it's not now. What's going on? Matter of me setting it to the right stuff? Turn the output down? No. Turn the output up? I mean, we've got plus minus like 3-ish volts going into this, which is perfectly fine for something like this. We had it before. It was doing crazy stuff. Yeah, either of these is fine. It's just 2 outs, 2 ins. Both of those should be doing the same thing. So let's see. Input is a frequency sweep. So we look at... We're going to have to do this on the scope, I guess. Double check my lab setup. We're not sweeping with a CV yet. And we're just looking at in versus out. And I'm trying to look at this on the scope. So, scope, let's get that. Oh, it's locked. Hold on. For the microscope. No, I'm looking at the frameless scope. Oops. No, you unlock it. Then I move. Oh no, that's locked. Wait a minute. Unlock it. There we go. Okay, just get that to where all the vertical video kids can actually see it. This is the wire and cable situation here is a little bit weird. All right, so first stop. In 1. There's our waveform exactly. So from in 1, hold on, I gotta look at the circuit at the same time. I got like 3 windows open here. Oh, I wasn't upping the range. I wonder if range could affect it? I don't know. Okay, hold on. Input 1 goes into just the minus of an amplifier, which I guess is probably this one. This is a TLO 6.4. I didn't have 7.4s, so I used 6.4s, and I think they're just the same. Output amp 1, output amp 2. Oh, so that's our exact sweep right there. We can just see the magenta waveform just kind of hugs the yellow there. So that would be the output going into another thingy over here. Where does that waveform eventually end up? 4 diodes. It ends up at 4 diodes on pins 15 and 7. 15 and 7 of these guys. So 1, 2, 3, 4, 5, 6, 7. And that's at the other side of the diode. One side of the diode, other side of the diode. Are these things getting power properly? I guess I don't know which pin is power for these. They're CDs, so... CDs nuts. Because there seems to be no activity on the clock, and I think that's kind of an indicator. Okay, let's see. What else can I check over? Well, the LSB should be showing us all kinds of activities. So if I go to pin 15 of, so 7, is it 1, 2, 3, 4, 5, 6, 7. So pin 15. 1, 2, 3, 4, 5, 6, 7, and 7 is 14. Oh, I'm on the wrong chip. Wrong chip. All right. 1, 7, 8. So this one is the clock. Okay, so we get weird clock signals. But the higher frequencies are not setting off the clock. I see these big jumps, and then they kind of boil away. So 13, 12, 11, and 2. Not really seeing anything going on there. Here we see jumps that look like clock signals. They're not fast enough. Huh. I don't know, is it like a bad value in one of these? Not really. These are the different channels getting their signals in. Maybe it's just a matter of controlling all the different controls on the front. to get all these mixed in properly. Interesting. I'm not seeing any like significant activity here, although there's really nothing wrong with the circuit that I've built. I don't think any of my components have broken. The TLO64 and 74 at the frequencies that we're using them should be the same thing. There's really not that much of a functional difference between the two. It's when you get into like higher frequencies that this stuff becomes a little bit more crazy. Turn all the feedback all the way up, depending on what direction these things actually go in. And then mess with the output. Turn these all the way up. All of it all the way up. We're blowing up the whole circuit. That's starting to do stuff. Lower the range. Up the range. Mid-range. Turn the feedback all the way down. I'm just not getting anything to happen here. This is range. So range all the way up, range all the way down, range in the middle. Range all the way down. Wait a sec, we were getting something. That does not look proper, although my outputs have been totally cooked. Turn the outputs all the way down. All of them down, all of them down, all of them down. Okay. Waveforms. Turn up the feedback. That one up here. 3, 4. All the mid-range. Okay. Stuff's starting to happen. That was when I touched the ground and something weird. Wait, I just bumped it. Was it not? Were we not getting a signal or something? I smell burning toast. Okay, what the fuck? I do not know what this filter's doing. It feels broken to me. That should not be sitting at like negative a couple volts, and it should be doing more than just freaking out on certain frequencies. So let's put all these in the middle. What's the middle for them? Flat like this, flat like this, flat like this, flat like this, U, flat like this. I've never seen something a little different. U, flat, U, flat, everybody in the middle. Everybody's going to the middle of the range. Okay, everybody middle, just like so. The only time I see the circuit responding is when the feedback from my own touch hits it. So I don't know what, that seems broken to me. We're giving it a normal audio frequency sweep. We don't have anything going into the clock. It should be clocking it off of the waveform, positive and negative. Although our waveform could be out of spec in some way. I can't do plus minus 10 volts from this thing, but audio signal in plus minus 5 volts is usually acceptable to these. What happens when I give it a full, we don't do the sweep anymore. I guess I can keep that plugged in. And instead of giving it the sweep, I'm going to give it the fixed sine wave that's full amplitude. Although it's a little slow, it seems. Yeah, see here it's actually doing something with the sine wave that's low frequency. There it is. So it's blocking it out into chunks, which is what it should be doing, but I guess this doesn't go into the negatives. Is that because of the amplifiers that I used? Or is it because of this adjustment? If I set these all down, no, that doesn't look like it's really doing it. These two are doing the lower quarter values. I guess this does just do... Oh, here we go. Juice all these up, will I get? No, not quite. What the hell is this thing? What even is? Oh, I see. Okay, spread. And then this one's range. This is going to do funky stuff. Just looking at the waveform and how it's splitting it up. But then again, it is clocking itself off of that waveform. If I had something higher frequency to put into that, so what if I sweep? I put a waveform sweep into the clock pin. Whoa. Definitely stuff. Wait, when did that offset happen? It's like it can go into the... Okay, what? That bin was controlling that. What the fuck? What? Huh? What the heck? So what's happening is we are sweeping through clock signals and we're hoping that it's a good division. Why did it go all the way up there? Stop that. Come back. What the fuck? Seems like anything nonlinear circuits really just needs to have like a module after it that's going to kind of rein in the chaos a little bit. If we put the range on a triangle wave, will we see the LED move at all? There it goes. Okay. Except that it's stuck. Did I freeze it? The scope isn't moving. The fast Fourier transfer stopped. What did I do? Is it scope? Buddy? Scope still works. Yeah, I don't know why everything's so locked in over there. Yeah, all right, so we're still operating. I mean, that's the range CV that I just plugged in, but it doesn't appear to be doing anything. Yeah, it goes from red to green. Oh, now it's just red and green. Oh, wait, no, it's actually doing something. We've completely lost our signal, though. Our output signal is just gone. I don't know what happened to that. Plug it into a different output. Unplug our input. What the fuck? How do I get this thing to work? Man, I'm gonna have to look up like YouTube videos on these because oh, there's some of it are back. Our feedback must have run into some kind of like a cascade. We resonated. You know, when I say resonance cascade, it means a much different thing than in Half-Life 1. Gordon Freeman to the testing chambers. So we can actually see the frequency sweep on that, on channel 2 somehow. How weird. What in the world? So somehow we're able to see the frequency sweep, but channel 2 is not really reacting by changing frequencies. We have a fixed sine wave going into this, and somehow our frequency sweep going into the range control, the range CV, is making it go weird. Or no, our frequency sweep is going into the clock control. That's controlling the rate of our clock. So really what we should be seeing is those bins zeroing in on that waveform and getting more and more accurate. But for some reason, the way it's interpreting the clock is not translating in the way that we thought it would. And these, I believe, are just our 1, 2, 3, and 4 bins. We've got feedback, and then we have output level control. So we can emphasize and de-emphasize our different outputs. With these all turned down, will we get more? No, that goes, why is it going way into the negatives? You're not going to be able to perceive that with a modular synthesizer setup. We're just all over the place, and I don't know why. Other than the fact that we are using a nonlinear circuit device, I would expect to see following the sine wave closer or further. Well, why are we only in positive for our output? Let's take a look at the output amplifier. It could be that actually we broke the whole thing. Wait. TL064. I now have the TL074s, and this is low power. Let's take a look at the data sheet here and see. Is it a puppy dog? I thought I just, hold on, I thought I just heard pause. Puppy dog? Nope, okay, I'm hallucinating. I could have sworn I heard the dog walking in. Or maybe she did and she just immediately turned around and went upstairs. That's what she does when I'm sitting at the lab stool. If I'm not at the lab stool, she will come downstairs and sleep under the desk. But very low power consumption, 200 microamps. Common mode input voltage range includes VCC plus. Short protection, high slew rate, I don't care about all that. TLO6X, family of industry standard operational amplifiers, mirror the TLO74 and TLO8 with low power consumption. Single, dual, and quad. So they should be very similar. Where are our maximums? Plus minus 18 volts. Okay, so yeah, we're good on that. It's something the circuit is doing that's sort of hitting our negative voltages, and it's probably just that this is how the circuit works. But I thought we should be sort of splitting this into digitals, which we are kind of doing in some places of the cycle that is actually doing that. But then I guess it gets overzealous. It gets too fast. So I wonder if I give it a square wave sweep, if that'll do. I'll do the same thing as the sine wave sweep. Huh. This isn't precisely confirming that this thing is working. But if we're not going into the negatives, that may mean that I need to look at the connection between these output amps and their power. And none of this stuff is labeled. We don't have U4C, U4D, E, A, B, C, and D. U4, A, B, C, D, and E then I'd be able to figure out which one these are. Which one goes to the output? This one would be primary among the ones that I would want to check to see if they are actually getting the negative 12 volts that they're supposed to get. And it could be that maybe the whole circuit is not getting negative 12. So let's check if we get negative 12 from here. So I'm going to clamp to ground and then check the output of the diode. Donk. That's out of, we can't see negative 12 on this scale. Hold on. Channel 3. All right, now I got plus minus 15 volts on that. Huh? Okay. What? Right here. Yeah, negative 12. Okay. Wow, really? Is my sine wave plus minus 12 volts? Huh. Probably should be 10 coming out of this thing, but this is going to 12. Now, let's see. Outputs are at the bottom of the board. So, original? Whoa. Huh. E2, E1, D4, 3, 2, and 1. So these are the controls for the 4. I don't really see anything happening on them. out. Yeah, so that's the same thing that we're looking at right now. And it's coming from over here, and then we should see negative 12, positive 12. So we are getting the full range there. Negative 12, positive 12. That one's good to go. Those don't worry about. Positive 12, negative 12. We got a handy dandy jumper right next to it. Are you? What are you? Yeah, you're the same thing. So positive 12, negative 12. Everybody is getting their appropriate voltages. I don't know about you guys. I don't know where your inputs are. Whoa, what is that? Wow, weird stuff going on. Same little dance with withheld permissions. So I really don't see anything particularly wrong with what's coming out of this thing. Seems like somewhere our signal is getting interrupted though. I mean, we are only 4 bits, so I guess maybe it's 4 positive bits. I don't know where that's occurring though. Where would that be limiting? I guess maybe in the, it's scanning from ground, but it's only a 1 or a 0 because the 4015 is, you know, a 2-state device. But we've got 4 bits that represent that voltage level, whether or not we've gotten to that bin through the diode over there. So I guess that maybe is what's going on here. 390, 200, 150 on whether or not it hits the threshold of the 4015 for both the clock pin and the input. And then the bit is carried over with the clock signal. I thought that would create a delay, but it doesn't look like there's any kind of a delay, which is interesting to me. But we can see the 0 bin, 1 bin, 2 bin, and a little bit of 3 bin, and then I guess we get a 4th. But it doesn't do negatives, I guess. At least from what I'm seeing, even though our waveform would gladly be going into the negatives. And then we get like a feedback, and I don't know what that's doing either. Turn all the feedbacks off. Now they're all negative. Take them to the middle. Now our signal just inverted and went up to 12 volts. Like, what is happening? That one appears to be feeding it back positive or negative on the number line. And if I take it to here, there's nothing until we get to weird higher clock signal shenanigans. So if I take the individual bins, if I give it a positive signal, lower and raise that one. Let's go from the bottom up then. I can't even see what's going on now that it's got the weird offset in there. Why does it have such a weird offset? And now it's gone. Now it's just gone. What the? We were doing something. We had something going, Walter. As far as I'm concerned, let me unplug our sweep. There's now no more sweep, and now I think it'll get a little bit more predictable because the clock isn't going to be weirdly like vibrating all strange. As soon as, look at that. My touching it was making it go shh. Is it just a sensitivity thing, or is that me doing that? It seems like it's getting feedback from... This one doesn't do anything. That bin does that? And I don't have the sweep plugged in anywhere, and yet... Oh no, wait a minute, the sweep's going here. Okay, so we still had the sweep going into the clock. So I'm going to undo that. What was the other one I unplugged? Oh, those are triangle wave going into our span. Okay, so span seems to be doing something with that. Then we've got our 4 bins that are separated by a certain amount. Looks like the bottom of the wave, the bottom 2 are not being represented by my settings. And that's the output. It just seems to flip us from positive to negative, which is a little weird behavior. I don't think that's correct behavior. You know what it might be? It might be the timing of the wave, too. In accordance with the clock, as it's flipping bits, flip, 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 flip in the positive, those are the 4 states that it's the 1, 2, 3 at the bottom, 4. No, that doesn't make sense. What the fuck is going on? What's going on, chat? Help. Helpers. The feedback widens our bins. No feedback. Like that. So that's the what is spread or whatever. I'm kind of getting the notion that when you mess around with these nonlinear circuits, you got to be real careful with the knobs. You got to be real careful with the knobs. I'm trying to understand how this works. That one just appears to send us. It's so weird because there's not, there's no chance the soldering is bad, right? There's no chance. I don't know. Is Twitch broken? I'm hemorrhaging users because cool stuff isn't happening, I guess. So I think I'm going to call it. We're getting up there. It's about closing time. So I'm going to be back probably Tuesday. You know, if I really feel it tomorrow, we can come back and do more of this stuff. But I think what I really need to do is create my audio interface so that I can do those sweeps. You know, I could probably do the exact same thing using Python 3 with my super duper powerful scope that's smarter than I am, but I would rather get exactly what's in the manual in order to make sure that I can tune this filter properly. And then in the end, it's probably down to me just listening to music through it and figuring out what effect the filters are having on the music. I'm gonna look up the digital filter simulator and maybe listen to a demo of it, because that clock input is kind of crazy. I don't know how that's working. It's something that I'm not getting in here. It's creating the clock through the input from the frequency input, you know, creates the clock, but then it biases it and then it puts it into the positive feedback of a 1 to 10, 10 to 1 voltage divider. So between positive power and ground, your clock is somewhere in there. That's why those positive parts of the waveform are what is feeding into that. I wonder what proper audio, I mean, maybe if it's like 5 volt offset, or it's, sorry, 0 to 5 audio, like you would typically, is that the typical audio that you would see in a eurorack setup? I don't know. Maybe my plus minus sine wave is not the ideal for these filters, for testing the filters. I'm gonna have to look that up. Anywho, hey, I'm glad you guys joined me for some of this stuff. We at least got to see some unique waveforms. Yeah, you put the lime in the coconut and you mix it all up. The only reason I know that is because of, well, the reason that I know that it's mix it all up is because of DBZ abridged. So anyway, hey, thank you guys for joining me. I really appreciate you sitting around and poking electronics with me. The digital filter simulator is kind of frustrating because it's built properly. It's like designed, I should say designed properly. It's designed so that everything is spread out and I can get all the solder in there and I can use the big parts and it looks good. And we've been able to poke all of the output stuff and I don't know, something's happening to our signal and I think it's maybe that it's assuming that we've got a positive offset audio going in there. I think maybe that's what it is. My plus minus 10 volt audio. That's what I thought Eurorack was, because you want all that voltage so that you have the clarity of this huge range of voltages, and then you can do stuff to those numbers in order to squiggle around all of your signals. But perhaps I ass you Mead. I made an ass out of Miu, and yeah, that's just where we are. So okay, let's see who we can if we can raid, who we can raid. Let's look at twitch.tv. and see if it blows my computer up. Twitch appears to have figured out somebody rolled something out to production and it broke the whole internet, I guess. Weird game. Rabaz is doing Sulfur. You know what that is. Sput is playing Approximately Up. I would send you guys over there, but simulator games are interesting, but Sput gets shouty. Flatulent Gonad. There we go. Let's just raid Gonad. Let us raid the Flatulent Gonad. Perhaps he's working on his simulator gauges that were frustrating him, or he's just putzing around at a game. I don't know what he's doing. Raid Flatulent. He has like as many users as I do. Raid Flatulent Gonad. It stopped auto-completing. What happened? That'll work. Okay, I'm going to throw you guys a Flatulent Gonad, and I'll catch you guys later. I'll be back Tuesday at the latest. Tomorrow, if I'm feeling it, probably not. I have a lot of stuff to do offline. And then we'll continue to get these things working so that we can get back to the big projects that we need to work on. I really want to be able to make squiggly noises, so we'll work on that. I'll see you guys later. Have a good one. Goodbye. And then for YouTube, I need to go to the screen with no microphone.